हाँ बिल्कुल आवाज आ रही है ना। यस माय नेम।
हेलो हेलो, आपका म्यूट करना।
वो बोल दो। हाँ बोलो।
हेलो,
नहीं म्यूट कर। आ रहा है म्यूट कर। हाँ। और वो निकाल दो।
हेलो
एक मिनट कर निकाल। हाँ बोलो।
हेलो,
ठीक है 2 में होगा तो कर लो। ये यूट्यूब चालू है। आपका माइक भी ऑन है।
किसका? मेरा।
मेरा तो बंद है। इसमें मुझे आवाज नहीं।
हेलो।
यस साई सीधा। हेलो,
गुड मॉर्निंग सर।
आवाज आ रही है?
हाँ सर आ रही है।
अभी थोड़ी देर में
आवाज।
मैडम ऐड हो रहे हैं।
ओके ओके ओके।
Hello. Hazır.
जी सर.
Hello everyone, good morning. We will shortly start our session. It will take hardly 5 to 10 minutes. So be patient and stay tuned.
Hello. A very good morning to all of you.
Good morning, ma'am.
I welcome you all on the occasion of second day of this international webinar. Sai Shikha,
Yes, ma'am.
please welcome all the participants and start addressing them as a filler.
Okay, ma'am.
Okay.
Welcome all the participants. Welcome all the participants. A very good morning to all. Shortly we will start our session, and as I can see, so many, around 46 plus participants are there. So It's feel very privileged that you all are here. You take time for this. So again, a very welcome on the behalf of School of Studies in Physics, Vikram University, Ujjain, Madhya Pradesh, India. Welcome, Professor Deepak Subedi, sir.
Welcome. Thank you very much.
A very good morning, sir.
Good
Today
morning.
is one of the speaker. So we heartily welcome you, sir.
My
Welcome
pleasure.
all the participants from different countries, cities. I welcome you all on the behalf of School of Studies in Physics, Vikram University, Ujjain, Madhya Pradesh, India.
Thank you so much for inviting me to share my experience in the field of my research.
Oh, thank you so much, sir. It's our privilege.
Good morning.
Good morning,
ma'am.
sir.
Good morning. Good morning.
Welcome. So you have joined in time.
So it is so nice to see you after 5 years. We were there
Yeah.
in 2015 in Ujjain. Very nice.
Yeah.
Yeah, we still remember the nice
Yeah.
time that we spent in your very nice guest house there in the university. Yeah, the photograph is the. Yeah, I remember. Yeah, it's okay.
Yeah.
गुड मॉर्निंग स्वाति मैडम।
नमस्ते सर।
नमस्कार, कैसे हैं?
बढ़िया सर, एकदम बढ़िया।
बहुत बढ़िया। आपका जो है वो कल का भी दोनों सुने, मजा आ गया। आज भी उम्मीद करता हूँ कि बहुत शानदार जो है वो चीजें सुनने को मिलेंगी।
बिल्कुल सर, कोशिश करेंगे। थोड़ा कुछ अगर त्रुटि रही हो तो सर क्षमा करिएगा।
नहीं, कोई त्रुटि नहीं। देखिए, अच्छे काम में कभी कोई त्रुटि नहीं होती, ऐसा मेरा मानना है ना। लेकिन वो तो उसमें सुधार और रिसर्च हमारी हमेशा चलती रहती,
बिल्कुल
कि और बेहतर कैसे किया जाए, है ना।
बिल्कुल।
क्या किया जा रहा है ये बेहतर काम है, लेकिन और बेहतर कैसे किया जाए ये हमेशा प्रयास होता है। तो इसलिए बहुत वेरी गुड और वेल डन।
थैंक यू सर, थैंक यू। गिरिराज शर्मा सर भी हमारे पीछे है। प्रोफेसर गिरिराज शर्मा इज ऑल्सो हियर। आप हुए हैं क्या? केकरे सर नमस्कार।
नमस्ते मैडम, गुड मॉर्निंग, वेरी गुड मॉर्निंग। कल का सेशन बहुत अच्छा रहा।
थैंक यू सर।
Madam, sorry, I could not attend yesterday's program because I had another pre-scheduled lecture at the time.
Yes, you were busy that time. There is no problem, sir.
Dr. Khanal was there yesterday.
Yes, Dr. Khanal was there, and he remembered those days of EIPT-2020 international seminar conference at our place, and he shared some of the photographs also in his slide.
Okay.
You were also there. Our first speaker is Professor M. Jamil from Pakistan, and at present he is not getting connected. So we are waiting for him, and then we will start, sir.
Pakistan time is 15 minutes late, madam. So I think that's why he's getting late, I think.
Madam, you are muted. Okay.
Actually, we have written standard time, Indian standard time in schedule, and he understood it very well. So let us wait for Professor M. Jamil. राम सर, आपकी तैयारी कैसी चल रही है?
बस बहुत बढ़िया चल रहे हैं मैडम। आपको प्रोग्राम मिल ही गए होंगे।
हाँ बिल्कुल मिल गया। और बहुत मेहनत कर रहे हो आप तो।
आप सभी का सपोर्ट चाहिए उसके लिए, तभी सक्सेसफुल होगी।
बिल्कुल बिल्कुल।
और लास्ट में आप इस कॉन्फ्रेंस की एक बार थोड़ा अनाउंस भी कर दीजिएगा।
हाँ 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 बिल्कुल।
रजिस्ट्रेशन अभी भी स्टिल ओपन है, अभी अराउंड 380 रजिस्ट्रेशंस हो गए हैं।
अच्छा
स्पेसिफिकली जो प्लाज्मा फिजिक्स के लोग जो काम कर रहे हैं उनमें।
अच्छा।
And yesterday I have also requested to Professor Kanal to chair a session also.
Okay okay.
And he's kindly agreed. So it will be good also.
स्वाति मैडम नमस्ते।
नमस्कार सर, कैसे हैं?
अच्छे जी,
बढ़िया।
बहुत बढ़िया, बहुत अच्छा प्रोग्राम है, बहुत बढ़िया।
Yesterday Dr. B
Dr. Venkatraman.
Chitra was also
Yeah, Chitra भी थी, right?
yeah. I have seen her name among the participants.
सब पिछले साल के सब लोग आ गए हैं।
हाँ सब लोग आ गए। ये तो होना ही चाहिए।
हाँ होना चाहिए।
प्रोफेसर दीपक सुवेदी भी यहाँ पर है नेपाल से। सर 15 में हमारे साथ थे, 2015 में।
वेंकटरमन जी नमस्कार।
हाँ नमस्कार सर, श्रीवास्तव सर नमस्कार।
कैसे हैं भैया?
अच्छे जी सर, अच्छे।
चलो बहुत बढ़िया यार, आप सब लोगों के चेहरे नजर आ जाते हैं तो बहुत अच्छा लगता है।
ये सेमिनार के बहाने वो हो जाता है सब बढ़िया।
बिल्कुल बिल्कुल बिल्कुल। और मैडम ने बहुत बहुत बढ़िया काम किया कि मतलब बहुत सारे पुराने जो अपने साथी हैं जिनको साथ बहुत दिनों से अपने कांटेक्ट में नहीं थे, वो सब लोग दिख रहे हैं तो बड़ा अच्छा लग रहा है।
करेक्ट।
Yeah, madam, I could see the photograph of the hall in which we had program in 2015. I think it is the hall where we had a meeting, maybe with the head of the department at that occasion.
हाँ 40 मिनट की वीडियो कर देंगे, 40 मिनट ज़्यादा
इसका वीडियो करो,
नहीं तो दिखने लगेगी कर ले।
मेरी आवाज वहां जाएगी तो नहीं म्यूट करनी।
Hello everyone. Before we start our talks and session, I'm having some announcement for all of you. During the talk, keep your mic and camera off. If you are having any questions regarding talks, kindly post it in chat box. It is open for all. At the end, we will convey your questions to the speaker. YouTube link is also shared by our technical staff to all the participants. Share it as much as possible. At the end of talk, you will get a feedback form. Do fill it because it is very important. And we will start our session shortly as our first speaker will arrive, will join us, then we'll start our session. As you all know that today's event is actually the second day of international webinar. As you all know, today's event is the second day of international webinar of emerging interfaces of physical science and technology, EIPT-2020. Entire team of School of Studies in Physics, Vikram University, Ujjain, India, heartily welcome you all. Our university, that is Vikram University, was actually named after the ruler Vikramaditya. It was established in 1957, and our department, that School of Studies in Physics, started in 1959. Till now, our department worked in many fields of research and development like space plasma, astrophysical plasma, solid state plasma, X-ray spectroscopy, astrophysics, nonlinear optics, nuclear physics. Kindly off your mics, everyone. Keep your audio and camera off.
Hello, good morning.
Especially keep this thing in mind when the talks during the talk, the mic should be off except speaker's mic. Welcome, Jamil sir. A very good morning to you. Our very first speaker, Mohammad Jamil from Pakistan, is now with us. Welcome, sir. A very good morning to you. Our first speaker, Dr. Mohammad Jamil sir, is now with us from Pakistan. Welcome, sir. A very good morning to you. As I was mentioning, the topics on which our department and our faculty members, our scholars are working from so many years are space plasma, astrophysical plasma, solid state plasma, X-ray spectroscopy, astrophysics, nonlinear optics, nuclear physics, nanotechnology, material science, and metallurgy. So these are the topics on which our team of School of Studies in Physics, Vikram University, Ujjain, Madhya Pradesh, India is working. Again, I will repeat the announcement for all of you who are new, who joined just now. For them, during the talk, keep your mic and camera off. If you are having any questions regarding talk, kindly post it in chat box. It is open for all. Don't do an unnecessarily chatting over there. But if you want to ask any question at the end of talk, so better mention it during the talk or before the talk ends, so that we will convey to speaker. YouTube link is also shared by technical staff to all the participants. So kindly check it and share it as much as possible. And at the end of talk, one feedback form link will be provided. So don't forget to give feedback, because it is very much important for us to improve in future.
Hi, Shikha.
Yes, ma'am.
Now Professor Jamil has joined us. So
Yeah, ma'am.
You should start now from your
Okay, ma'am.
formal. Okay.
Okay, ma'am. Okay, ma'am.
Professor Jamil.
Hello, sir. Are we audible to you? Mohammed Jamil, sir. Can you hear us?
इनको unmute कर दो ना. Professor Jamil.
It is muted by the host.
Professor Jamil.
Yeah.
Could you hear us, please? Professor Jamil. दो नाम से कहाँ है? मेरे को तो एक में ही दिख रहा है सुभाष.
Hello.
Hello. Yes, sir. Jamil, sir. Are you there?
Yes, I'm here.
And are you ready with your PPTs?
Can you listen me?
Yeah. You are audible, but which is your ID, sir? There are two M Jamils. Please make your video on, sir. Subhash? Again, 8 minutes. Ha. Yes. So shall we start, sir? Sai Shikha?
Yes, ma'am. Now I will start.
Now you can start. Sir is ready.
Okay.
सर को आवाज नहीं आ रही है.
Call on internet, I think, is not there.
ये जामिल सर को आवाज नहीं आ रही है जो प्रेजेंट कर रहे हैं. हाँ, उनको टोटल आवाज नहीं आ रही है. प्रोफेसर जामिल, am I audible?
Hello. Sir, on the left hand bottom corner, you will find an icon which says join audio. You need to click on that. Hello.
आवाज नहीं आ रही.
दो है क्या सुभाष? Hello.
बोलना तो.
तो एक.
Why not? I'm listening here.
Hello. Sir, we can hear.
Hello. Yeah.
Yeah, so you're good to go.
Actually, I was not listening you. So I have withdrawn from the mic now. I'm using the computer speaker.
Okay.
So can you listen me?
Yes. You are audible enough. And now we are carrying on. Sai Shikha, please start.
Yes, ma'am.
Okay.
I request once again with all the participants, kindly off your audio, except the speaker. Rest of all, you have to keep your audio and video off for the better audio outcome. A very good morning to everyone. On the behalf of entire School of Studies in Physics, Vikram University, Ujjain, India, I am your host, Sai Shikha Naidu. Welcome you all on second day of 2 days international webinar on emerging interfaces of physical science and technology, EIPT 2020. Vidyam cha yastadve do bhayam saha avidyam mrityum titrava vidyamritam shute. Means knowledge leads to immortal. With this motto, let's begin with the second day session of EIPT 2020. Before any further launch, I would like to share some day one glimpse with all of you. In day one session, two eminent speakers delivered their talk. Professor Arup Niyogi ji from North Texas University, USA, caustic material and elastography from North Destructive of Materials and Bioimaging. Professor R. Khanal from Tribhuvan University, Nepal, shared their knowledge on kinetic trajectory simulation of plasma ball transition regime in magnetic fusion devices. More than 150 participants were connected with us on day one through Zoom app and live tube streaming. I feel privileged to announce that we are having three eminent speakers with us today. Dr. M. Jamil, Islamabad, Pakistan. Second, Professor D.P. Subedi ji from Kathmandu University, Nepal. Welcome, both of you, sir. Third, Professor G.R. Sinha, MII, Myanmar. Welcome, sir. A very warm welcome to all three speakers in international webinar on emerging interfaces of physical science and technology, EIPT 2020, day 2. Before initiating our today's session, there are few announcements for all of you. During the session or during the talk, keep your mic and camera off. If you are having any query, questions regarding talk, kindly post it in chat box. It is open for all of you. At the end, we will convey your questions to the speaker. With this Zoom link, YouTube link is also shared by our technical staff to all the participants. Share it as much as possible. And at the end of talk and the session, you will get a feedback form link. Don't forget to give a feedback. It is very important for us for the further events. Again, I would like to welcome our today's speaker, faculties, research scholars, students from different parts of country at international webinar on emerging interfaces of physical science and technology, EIPT 2020, organized by School of Studies in Physics, Vikram University, Ujjain, Madhya Pradesh, India. We welcome you all. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. So definitely everyone who are connected here with us having capacity, ability and 100% willingness to learn. So good things come to people who wait, but better things come to those who go out and get them. With these inspiring lines, I would like to invite Dr. Swati Dubey ma'am, Head of the Department, School of Studies in Physics, Vikram University, Ujjain, Madhya Pradesh, India, for welcoming address. Over to you, ma'am.
Thank you, Shikha. So it's my proud privilege to welcome all of you on the occasion of this international webinar on emerging interfaces of physics and technology. And this is the second day of this webinar. I am very glad to welcome Professor M. Jamil, Professor Deepak Subedi, and all the respected professors from not only India, but also from other countries, and research scholars who have joined us. And now this is the time to introduce Professor M. Jamil. Dr. M. Jamil did his PhD under the supervision of renowned professor M. Salimullah, and under the co-supervision of Professor H.A. Shah, ex-Vice Chancellor, GC University, Lahore, and under the patronage of Professor G. Murtaja from GC University, Lahore in the year 2012. Currently, he is serving at the Department of Physics, Comsets University, Islamabad, Lahore campus as an assistant professor. His research interests are in the areas of linear and nonlinear studies in classical and quantum plasma. He is very active researcher, and till date he has co-authored 60 research publications in various international journals of repute. And he is humble enough. He wants to be introduced as an humble student of quantum dusty plasma, even after so many publications in various journals. And I wish to tell you that his group is with our collaborator. They are among our collaborators also. Professor M. Salimullah and Professor S.K. Ghosh had a strong research collaboration, and hence Dr. M. Jamil happens to be co-author of some of our research papers of Professor S.K. Ghosh and Dr. Nishchhal Yadav. So I welcome you, Professor Jamil, and now I request you to proceed. Over to Jamil, sir.
Are you listening me?
Yeah, now you are audible, sir.
Yeah. There was some message of unmute. So I'm thankful. I was giving thanks to all of you who have given me an opportunity to talk with the big community of plasma physics. Of course, knowledge have no limits, no borders, and it is our good luck that every bads many times have many goods. Like the COVID season restricted us at homes, but beyond of limit. So it's so I would like to say greeting to Professor S.K. Ghosh, and if Professor Tripathi may listen me, I'm not sure he is here or not. I will also say my greetings to him. Now, going towards my talk, I would share my understanding about the coupling of waves in quantum plasmas. Here, this slide show on the right side picture is the entrance view of my department, Department of Physics, Comsat University, Lahore campus. The lower figure, this is for the case of for the purpose of motivation. The one figure which is before the arrowhead, maybe you could see my pointer. So this figure is, this part is showing that every field.
Excuse me, sir. Your screen is not visible. Please share screen.
Okay.
Earlier it was visible.
Yes, sir. We can see your screen. You can proceed.
Thank you. So the lower figure is pointing, the first part is telling us that the research particularly is not a simple piece of cake, but if you have determination and confidence within you, and if you have good luck to avail a good supervisor, then this stumbling stone will change into a stepping stone. About the plasmas, plasmas are not like molecules, for example, gaseous molecules, but it has negative as well as positive charge species. Electrons are very mobile due to small masses, and ions are less mobile due to its mass much higher as compared to the electrons. A third species, which is called dust, due to the discussion or after coming literature, go through the literature, we came to know the role of the third species, which is known as a dust, and the plasma that will be hosting dust along with the electrons and ions, that will be called the dusty plasma. Dust particles may have a spherical shape, or through some literature we came to know that sometimes it exists in the form of elongated rod, and also some form of the pancake. It is most of the time it is negatively charged due to very higher mobility of electrons. However, some other processes are also involved, for example, secondary emission, that make the dust particle positive. So positively charged dust or sometimes negatively charged, depending upon which process is involved there. Dust particles are much higher in mass as compared to the electrons and ions. And some reference cite this size even 8.0 times 10 raised minus 12 grams. And its nature is as the plasma predict different features at a time.
Excuse me, sir. Kindly
Yeah.
make it full screen. Make your presentation full screen.
Is it okay?
Yeah, sir. Yeah, now it is okay.
Okay. So dust is sometimes behaving like conducting, and another time we also perceive its property of dielectric medium. If I would try up to some extent to express in a figure the interaction of particles in electron ion plasma, shown by the bottom left figure. This is somehow analogy, not a perfect perception. If I could express the interaction of particles like this figure, then the addition of dust may cause very complex situation shown on the very next figure on the bottom. So it means the dust plasma is not a simple case. It has many processes at a time carrying on. Where we can find the dust or dusty plasma, we can divide into three major categories. One is the solar system, where Saturn rings, comet tails, interstellar medium points out the presence of dust. In manufacturing, while silicon wafer processing, the particle contamination may appear like a dust, or in the process of nanomaterial synthesis. And as a basic physics, we learn the study of dusty plasma waves and also in the for the case of fusion devices, the dust, it's another case whether its role is positive or negative, but it is observed that the dust is present in fusion devices. If I would try to categorize the plasmas, then I would say the plasma may be homogeneous or inhomogeneous. Similarly, the magnetic field may be homogeneous or inhomogeneous. By nature, the astrophysical magnetic field or Earth, that is not the uniform. However, whenever we take the magnetic field as a uniform field or constant, we consider a very small region where field is minor changes. So density gradient as well as the magnetic field gradient is a natural phenomena. So what are the effects of these gradients on the species? The top left figure is showing how the electrons and ions behave when are fed into the magnetic field. They gyrate and the radius of gyration depend upon their mass. If I replace this particle into the stream of the particles, top central figure is showing the stream of particles, and when this stream of particle is placed inside a magnetic field, then we see the circle of the stream. And on another hand, and the lower figure on the left side, this is the case when electric and magnetic field both are applied. And the middle bottom figure explain when we have density gradient, and this density gradient and at the last right side bottom figure elaborates when we have electric and magnetic field gradient. It means density gradient is there as well as the magnetic field gradient is there. So the bottom two figure on right side elaborates what happened, the trajectory, how the trajectory may be perceived when we are studying the inhomogeneity in the magnetic field or inhomogeneity in the density. So this is because the inhomogeneities is very crucial to tackle. It's not simple to tackle. And another classification may be possible as classical and quantum plasmas. Classical plasmas usually perceived as high temperature plasma, and its density is low as well, and its Debye radius having fewer particles. Definitely due to the thermal motion, there will be a thermal pressure. But it is very interesting that, and we all of us know that the every particle, bottom left figure is showing the butterflies. Insect of butterfly should be taken as a particle like electrons, and the wings of that butterfly should be considered as the de Broglie wavelength associated with the electron. And here we perceive that particles, no doubt, occupy the de Broglie wavelength, but not interacting with each other. Their wings are not interacting. So this is the situation when we ignore the quantum effects. On right side, we see in comparison to the classical plasmas, there is a quantum plasma which is usually taken are considered as the low temperature plasma and the high density plasma, which has enough number of particles in the Debye radius much higher as compared to the classical plasmas due to its natural reason of higher density. The thermal pressure is replaced by the Fermi pressure for the case of quantum plasmas. However, sometimes Fermi quantum plasma do have some thermal effects as well. And the right bottom figure again showing a butterfly, a very high concentration of butterflies, pointing that the quantum particles now their de Broglie wavelength is strictly interacting with each other. So the main criteria that differentiate the classical and the quantum is whether the de Broglie wavelength is interacting. We can say the interparticle distance between the classical particle is larger than the de Broglie wavelength, whereas for the case of quantum particles, interparticle is smaller than the de Broglie wavelength. Therefore, some another properties, some another forces come into play. And where could we find the quantum plasma or the dusty quantum plasmas? White dwarf, neutron stars, magnetars, laser-produced plasmas are commonly known examples. However, with different densities, are commonly known examples of quantum plasmas. However, there is a big question mark in front of dusty quantum plasma. No doubt, there are some arguments in the favor of presence of dusty quantum plasmas, and some people are yet not agreeing and not believing that the existence of quantum dusty plasmas. But I believe a statement which I have written here, that the theoreticians of the 19th century proved that flying was impossible. In the 20th century, they retreated to the statement that flying is impossible unless the airflow is confused and disordered. So now the situation has been changed for the case of flying. And similarly, we are the theoretical people. Theoretically, ideas are floated, and with the passage of time, experimentalists do prove the claim. If it is proved wrongly, even it's not a failure. So the wrong argument based on some scientific principle will also not a wrong. Another feature, there are the properties which come into being when we talk about the quantum plasmas. One on the right top figure, that is the Fermi degenerate pressure. It's a statistical pressure. When for the case of non-degenerate gas or medium, the figure elaborates that there are empty states. But for the case of degenerate medium, all empty states are completely filled. And the upper level of completely filled, this energy of this level is Fermi energy, and the temperature associated with that energy is Fermi temperature. So when this situation comes, due to Pauli exclusion principle, another particle cannot enter into that state. In this way, some particular type of the pressure which is quite different than the thermal pressure is experienced by the plasmas. The second feature that we are commonly known by the tunneling potential, which is represented by the Bohm term. Usually, if they here as the right bottom figure is clearly elaborating that for the classical physicist, one has to climb over the potential barrier, but for the if the particle is quantum, on both sides particle interaction may tunnel through the barrier. This phenomena is purely quantum mechanical phenomena. This no doubt its contribution is not so enough. Mathematical data and its numerical analysis do verify that this part or this contribution is very small. However, it depends upon when we translate the grade term into using through the Fourier transform, then it cannot even be ignored. On the left top side, side, three figures showing some few pairs. The top one is elaborating two particles having spin in opposite with opposite spin. And the lower figure, this if these two try to get this form, the particle spin will not let them to sit like that. The particle have to again get this state, may get this state. So from the top first and the third figure, no, we perceive that their position is changed. However, they are oppositely spin, having opposite spin. So this exchange, this involves some interaction of energy, some potential, and potential involved in this mechanism will be called as the exchange potential. And when these and the bottom figure on left bottom is pointing, when the particles or exchange feature is preserved during the dynamical situation, it means this term or the exchange correlation potential have origin from the DFT. No doubt I'm not expert of the DFT, but this term even almost in magnitude, if we do comparison of Fermi pressure and the pressure due to exchange correlation, these are somehow comparable. From the numerical analysis we have perceived, we have evaluated, almost probably equal contribution is there. So we know the plasma hosts a huge variety of the waves and instabilities. I would categorize a group into few like drift instabilities, fluid instabilities, wave stiffening or harmonic shocks, solitons, self-focusing, wave collapse, wave turbulence, mode coupling, phase space vortices, new nonlinear phenomena. All the possible interaction of the waves with and without the magnetic field. I would focus right now up to some extent on the mode coupling, which is the coupling of the waves. So this is not the complete list because this list is still continuing, but we will focus on that. So when we talk about the possible coupling of the waves, even we can somehow categorize the coupling mechanism, depending upon their mechanism. So I would show a few ones. We send some electromagnetic wave. As a result, we get trigger the two electromagnetic and electrostatic, which is electron plasma waves. This is usually known as stimulator Raman scattering. And the other one is the when electromagnetic waves trigger electromagnetic wave and the ion acoustic wave, which is stimulator Brilliant scattering. And similarly, the following other categories we can perceive. And on the next one, one of the following is when parametric decay instability. When electromagnetic wave triggers electron plasma wave and ion acoustic wave. It means when electromagnetic wave excite or generate two electrostatic modes. Here we even know this term of parametric decay instability it has become a very general. From here, we are defining a particular category, but it has become a very general. Usually, literature verifies that whenever we say three-wave coupling, people consider as the parametric instability. Just because all of these interaction should satisfy some conservation laws and which are valid almost for all of the cases. Therefore, it is usually perceived that the parametric instability is a quite wide term. So even three-wave mixing can be of two types. One is non-resonant. When there is for that case, for non-resonant case, there should be a pump or the exciting wave should be a virtual wave. This is another part, but we are focusing on the case of a resonant mechanism of three-wave interaction. So non-resonant mechanism have Landau damping. It means when the two waves couple, as a result, mode come into being, and that newly evolved or excited mode will damped through the mechanism of Landau damping. This will be considered as a non-resonant mechanism. While here we are using the resonant mechanism approach, which this process can be elaborated by few steps. Step one is showing few particles, dots, or this is the plasma medium, and green wave, this is the pump wave. So the medium has seed wave. On left side of the step one, you see there is due to the oscillation of particles, the plasma host large number of waves. So one of the wave may be taken as the seed wave. When plasma pump wave, which is the energy source, it may be from the external source, or if we fix some region and the wave entering from the other region of the same plasma of higher amplitude may be taken as the pump. So the step one is elaborating how the seed and pump may interact. In step two, this interaction will scatter the pump, and the new wave, which is shown by red color in the figure in step two, this red color have almost not exactly equal, but a small difference of the frequency. So as a result of interaction in step two, the pump wave is scattered, and now we have three waves. One is the pump wave, other one which is the energy of source, other one is a side band which has probably equal frequency to the pump, and the third is very low frequency, which is the seed still existing here in step 2. Step 3 shows the two almost similar frequencies will experience a beat wave phenomena. So beating of these two nearly equal frequency modes will evolve an envelope of low frequency. If we are not believing this mechanism, then a pump, as shown in the case of step 1, pump and the seed can never interact with each other because they have quite different scales. So now the envelope have a time scale comparable to the seed. So as the figure step 3 shows how the particles are trapped, and these trapping mean some fastening the oscillation, and in this way we may get amplified seed, whereas that depleted pump is not depleted. So this mechanism is actually we are studying in our, just after a few slides we'll have some work problem here. So during this mechanism, from the left bottom figure, we see equation of conservation of energy. Is omega naught is the frequency of the pump, and omega 1 is the frequency of the sideband, and omega is the seed frequency, which is the lower frequency mode. Any that may be among these three, any may be electrostatic mode or the electromagnetic mode. And the bottom expression is K naught is equal to K1 plus K, which is the conservation of momentum. So it's a vector equation. So momentum and the energy both should be conserved in this process, which is the basic principle. So as we are going towards a work problem, so some tools which are mathematical tools that should be applied here. First one is we linearize the equations in the 0th order, and then first order, and then second order. I would develop some analogy with some natural scenarios. The top left figure shows can represent the equilibrium part, 0th order part, and the top middle figure may elaborate the first order or the first order perturbed quantities. So how first order quantities be perceived, this is we have done to our best to elaborate this phenomena. The last top rightmost figure is the second order. When we linearize, this scenario should be in our mind. Remember, the quantities, if we see the top leftmost and the top rightmost figure, the quantity of water which has been is going to be perturbed is much smaller as compared to the equilibrium part. So this, in other words, for the case of Taylor expansion, we say the first term is the maximum, the first 0th order is the maximum value, first order number, perturbed number density is less than the equilibrium, and the rightmost last term, which is the second order, this quantity, such quantities are very much smaller, which may be discussed in the case of soliton or such like studies. Fourier transformation is another tool, mathematical tool. Suppose if we consider a water pool that would have large number of waves, and which wave is of our interest. This selection should be maybe done through the Fourier transformation. I have shown here a boy selecting some football from one's choice. So on the bottom left figure, this is showing large number of waves plotted here. And after the filter of Fourier transformation, the bottom middle figure shows how the frequencies are now separated. So here it depends upon which frequency is of our interest. Another thing that should be discussed is the Pondomotor force. If I try to give some analogical picture, mechanical analogy, I can somehow take the concept of fluctuating or oscillating pendulum. Here, in order to understand the Pondomotor force, we have to replace the force by some impulse. So we know that in this case, the impulse will be in vertical direction, while the pendulum bob has to move along the arc. From this, we can say the impulse is some component of the arc path. So if it does feel a downward impulse at its low point, that will set it up for a greater upward impulse as it goes down. What I want to say here, that is discussed from the bottom statement for the case of charged particles in an oscillating electromagnetic field in terms of radiation pressure. You know, higher the field strength intensity, have the higher the radiation pressure. So when oscillating electromagnetic wave is passed through the are striken to the medium, the particle will be driven by the pressure imbalance from higher field to the weakest. So this is basically my understanding of the Pondomotor force. Pondomotor force was discussed in 19th century and nearly has forgotten. People for a wide gap have done no work on with the application of Pondomotor force. But in 20th century, with the invent of laser field, Pondomotor force came to prominent. Pondomotor force have many types or categories, but I'm just discussing few ones. One is distinguished by their dependence on temporal or spatial wave intensity derivatives. And the other type is the Barlow force due to the particle collision. This force is the independent of wave intensity derivative. Now, so thinking all concepts that I have just discussed, keeping all these things in my mind, we have done a problem, and I would go through that problem, how these concepts of Pondomotor force and I'm taking here the geometrical figure is shown here. You say K is the wave vector of dust lower Hubbard wave, and K naught is the wave vector of dust on acoustic wave, while K1 is the wave vector of shear L1 wave. So in this way, the laws of momentum, vectoral addition is K naught. This is the resultant, K naught. the resultant of sum of K1 and K, which is the conservation of momentum. And how these particles are interlinked, components are related with each other, we can understand this simple graphical or vector notations are there. One thing is here, theta is a small angle making the wave vector K along the horizontal, while theta 1 is an angle which here L1 wave, which is actually sideband, make an angle with the magnetic field or z-axis. Theta is dependent upon, they are interly linked with each other. The expression below, after resolution of vectors, we get this expression. It means for numerical analysis, we shall only control theta 1. Controlling theta 1 will provide the variation in the theta as well. So we consider a plasma system which is consisting upon the three species: electrons, ions, and dust particles. Dust particles are taken negatively charged. Dust and ion, as are of higher masses, therefore taken classical, while electron being a lighter particle, they are treated as the quantum particle. The first momentum balance equation is a general equation which shall be applied for the analysis of all modes. Few features will be taken for the case of sideband and for the case of pump, and so it means J. Here, one thing, J is representing the electron, ion, and dust. On left side, every one of us knows that it's a Lorentz force, and the next on right side is the quantum effects, and the last one is the nonlinear effects which come through the convector term. So this convector term should elaborate the quantum motor force. As we discussed here, that the pump is electrostatic, sideband is an electromagnetic, and the seed, which is the low small frequency perturbation, is the dust lower Hilbert wave. So for the case of electrostatic, we need the continuity equation and Poisson equation. We shall couple the continuity and Poisson equation to get some expression like that. Here, the epsilon phi is proportional to the nonlinear, Ne nonlinear. Here, Ne for the electron number density and NL is the for nonlinear, where the simple L should be used for the linear. And for the electromagnetic mode, which is shear L1 wave, we will solve the Maxwell equation and we'll get this expression. No, actually, the last two equations shown on this slide have to couple with each other. You know, J1 nonlinear, this is a current density. Nonlinear current density should contain a nonlinear number density that will be substituted from the second last equation. In this way, we will get a coupled expression. So remember, our main target is to evolve these two equations, and up till now, it will be called as the linear analysis. And when we couple these equations, this will be, this give us some nonlinear coefficient, and coupled mode should be evolved. So we are now considering the linear response of the pump. As we discussed, the pump wave is denoted by omega naught k naught, which is a dust ionocaustic wave. Using the momentum balance equation, we find the velocity vectors and number densities. Here we define G naught J is and Vf, these are the few factors representing. And finally, as it is the electrostatic wave, we get generalized susceptibility relation chi for J. Now, as we are talking electron, ion, and dust, J will be substituted for electron, then V Fermi will do exist. And when we take J as the ion and dust, then this Fermi factor will vanish, and then equating to unity, where epsilon is equal to 1 plus chi E plus chi I plus chi J. When we equate to 0, this will provide a dispersion relation of dust ionocaustic wave. And the second mode, which is the sideband, for its linear analysis, again, we go to the momentum balancing equation, but yet we are not taking the last term, which is, again, if you recall, okay, I'm having some problem and not possible to go back. So I'm continuing from here. So if we consider simple momentum balance equation, ignoring the convector term or nonlinear term, we will find its velocity. Here you see the x component and z components are given here, and g and f are the factors which are defining on the right side bottom. F and G both are quantum factor having V Fermi. So if we ignore the Fermi effects, it means all quantum effects are residing inside the V prime. If we ignore these, then we'll get F and G as unit. In this case, after putting G and F1, we will get a simple textbook expression of the velocities. Similarly, current density, we revolve. For the current density, we split J1 linear and J1 nonlinear. As we discussed, J1 linear should contain the linear velocity component, and for nonlinear, we'll have this nonlinear current density is derived from the convector term, which is N static V naught J. N is the number density of seed, and V naught is the pump. So it means when we are finding the nonlinearity which affect the sideband, we'll couple pump and the seed. And when we find the nonlinearity effect on the lower hybrid, then we'll consider the pump and sideband. So after following a simple algebra, we get linear dispersion relation of the sideband. Now, for the linear response of dust lower hybrid wave, again, we shall go to the first equation and finding the velocity and number densities. We'll now substitute number density in the Poisson equation, and we'll get the dielectric response function, which is epsilon function of omega k is 1 plus sum of chi j. And here chi j is defined when we are again if we see the denominator, the last term of denominator has Fermi effects. For the case of ions and dust, this will be ignored. So we'll have, and after simplifying, we get the chi e, chi I, and chi d. Getting the summation, we'll get the epsilon. Till now, we have covered the two steps because in the first step and second step, we are playing with the linear path. And now we are going to play with a nonlinear part, which at step 3. For step 3, if you recall, the first equation we discussed was the quantum force nonlinear term. This quantum force having the velocity components of and the vector component of sideband and pump, and the last term having the velocity and the field of electromagnetic wave. From here, we'll find the nonlinear velocity. So when we substitute velocity components and the electric, and after doing a simple algebra, we'll get it as the nonlinear number density. And in the first slide of the problem, we were discussing an equation which contained the nonlinear number density. It means now we are targeting to that. This nonlinear number density having the pump and side band effects, which is elaborated. Phi naught is the pump potential, and E1 X and E1 as Z are the electric field of the sideband. Similarly, following initially we have written the formula for the nonlinear current density which have been evolved. So after substituting this nonlinear density, current density, and the number density, we have coupled the equation, and after coupling these two equations that we have earlier discussed, we'll get an equation of expression epsilon is equal to mu over d1. Here you see mu is the coefficient of nonlinear coupling. It means if pump, which is given below, which is having a square of potential of the pump. This is, the quantum force has been represented in different manners if we go through the literature. So, however, the main thing is the square of amplitude of the pump, which is shown here by the phi naught square. If phi naught square is 0, then we'll get epsilon times d1, which is the dispersion equation of the sideband. So the product of both should be 0, and on equating to both epsilon 0 and d1 0, we can get the dispersion relation of linear. However, now we'll get the so for the growth rate, this parametric three-wave parametric instability is derived on expanding the epsilon and d1 around the resonant frequencies. We'll get where omega L and omega L1, gamma L1 will be 0, and that will give us final. After this expansion, we get the growth rate of three-wave coupled mode. And when we substitute these expressions, we'll get the final expression of the dust lower hybrid. Now, for the results and discussion, because this is the final part of our results, to gain numerical appreciation of our analytical results. The growth rate of nonlinear dust lower hybrid wave is studied for the following set of typical parameters. This set of parameters and density, like, and not is the equilibrium number density, and not D is the number density of the dust, and phi naught is the potential of the pump. So after employing this data into the growth expression of growth rate, we'll get some results. So the first slide of this graph is the dispersion relation. The figure 1 left shows the dispersion relation of test ion acoustic. The purpose is to explore its linear characteristics. The plot is used. So this linear characteristics is used to analyze the suitable range of pump wave vector and the corresponding frequencies that should satisfy the phase matching condition. You know, in the previous slide, we have learned about the conservation of momentum. K naught should be equal to the K plus K1, and the omega naught should be equal to omega 1 plus omega. So it means the two quantities will give sum. So these graphs will help us to find which range will suitable. For example, if our target is to get 10, then 1 plus 9 should be equal to 10. And the last term may be 9 plus 1 should be equal to 10. In this way, this range would define. Why we were interested in this, because there are different scenarios where some particular kind of wave having a particular wavelength is not existing. Place to place, the waves are different wavelengths are existing. So how much possibility is there to interact these waves to evolve this phenomenon? The suitable range of wave vector helps to diagnose different physical scenarios where three-wave coupling may trigger different frequency, I mean beat frequency signal generation. Such a triggered signal may play its role either constructively or another way around. If you could see the figure, the left figure, here K naught is suitable range that it would justify to our results is from 2 to 3 times 10 raised 2 per centimeter. And similarly, on the right side figure shows the purpose is same and its range is again 1.022 times 10 raised 2 per centimeter. So the both figure, if we consider the both of the figures left and right in combination, point out the parametric coupling is not bound with some particular pump. It means some particular pump is not necessary, but some range can satisfy this. And the next is the graph for the case of here we are observing the growth rate with variation in side band, angle theta 1 as well as on varying the magnetic field. If you perceive the topper curve have a 2 times 10 to the 5 gauss, you know, astrophysics region host magnetic field from literature we found it may be up to 10 to the 12 or more, even beyond. But we are taking a very minimal uh, magnetic field, and the topper curve is the highest magnetic field and the lowest curve having the least magnetic field. This figure depicts the curves of decreasing growth rate at different magnetic field strength, which shows that higher growth rate is achieved at the upper limit of external magnetic field. The highest applied magnetic field retains the least limit of the growth curve much higher than the growth at comparatively lower magnetic field. What we perceive, what is happening physically inside the plasma, we believe the gyroscale highly coupled in phase with the oscillatory beat scale at small angle theta 1 to excite the dust lower habit. At small magnitude magnetic field, the gyro frequency of species decreases and does not match with the wave frequency to less excite the growth rate. In the same way, on increasing the angle theta 1, the palm and side band fields poorly interact to excite the low frequency beat wave spectrum. This is our perception, our discussion about, and the next graph is again growth rate variation in the sideband angle theta 1 by varying electron number density. These few graphs are on horizontal is the angle in degrees and against the growth rate on varying different parameters here. Number density of electron, equilibrium number density of electrons is varied. This, if we see the figure, this elaborates decreasing growth rate at varying the equilibrium number density. If you recall the geometry, if we increase the angle theta 1, logically the growth rate should increase, and which we are perceiving here. The higher concentration of equilibrium number density shows the least curve of decreasing growth rate of the beat wave against the theta 1. The highest curve with decreasing tendency of growth is obtained at the lowest electron density. What may be mean the highest curve at the lowest density? What may be the physical reason? We perceive that physically the smallest electron concentration inside the medium, because we are not reducing overall number of particles. The contributing electrons are reduced. So where are the rest of the electron? It means they are eaten up by some dust particle. So this is possible. At some time, dust would eat up more electron and sometimes less electron. So when in the medium we have fewer electrons, it means dust particle have been eaten up large number of electrons. So this is, we can say that when, as a result, what happens when the more electrons are eaten up by the dust, this reduces the electron number density. Therefore, the dust dynamic becomes effective to contribute for the higher growth curve. This is our perception from the graph. And for the next curve is response of growth rate with variation in sideband angle theta on varying the pump wave vector. This figure, if you see, maybe it is clear or not, this figure interprets the behavior of decreasing growth rate with different momentum imparted from the pump wave. The maximum momentum H bar K naught transmitting from the pump wave fed to the higher growth rate of the dust load hybrid wave propagating at the beat frequency. And the next graph is when we now consider magnetic field. For the case of on horizontal, we are having magnetic field against the growth rate, and we vary the number density of the particles. Here, this figure describes the increasing instability curves as the electron equilibrium, because here we have fixed the angle where we get the maximum growth for that particular angle. If we increase the number density, then we get the increasing curves as the electron equilibrium number density is taken the lowest. Typically, the highest electron number density develops the higher frequency that resonates hardly with the lower hybrid. Logically, higher number of electrons definitely would have a high frequency, and a higher frequency scale should exist there, which will, I'm seeing some hand, I don't know, is this for me or not?
No, it is not for you, sir.
Okay.
And please make your presentation full screen, sir.
There is some issue with me. Okay. I'm trying, but having some issue, I don't know what is there.
Okay, sir. Let it go.
So otherwise, you have to show your patience, please. So physically, I believe the highest electron number density develops the higher frequency, and we'll get higher scale, which will not resonate with the low frequency. This is one of the possible reason. There may be a large number of possible reasons. However, the next graph is again for magnetic field against the growth rate at different angle theta. You know, some particular angle theta would justify the resonance, and for that particular up to that, when we increase from lower value to the particular value, the growth rate is increasing. So this again elaborates the different curves. As you see, it is observed that the least angle between the pump and the side band wave vector results in maximum instability. You say this is a 2.1 degree. At minor increment of θ1, an immense change in the instability curve is noted as compared to the other curves. What we perceive physically is a small angle can only expedite the instability for the reason for effective interaction between pump and the sideband, whereas a larger angle limits the field effect over the plasma. And the next curve is response of growth rate with variation in magnetic field by the varying pump wave vector. Again, we see This figure reflects the highest growth curve obtained at the highest magnitude of pump failure. As we discussed previously, the largest value of K naught reflects the maximum magnitude of the momentum. So it is due to the enough energy carried by the pump wave. For that reason, it is perceived that we get the growth rate maximum for the maximum highest value of the wave vector. Now, at the end, I would go to the conclusion. 3 points we noticed here. A countermotive force is developed due to the beating of the pump wave and generated sideband to derive the low frequency, the slower hybrid wave. Growth rate tends to maximum at angle 1 to 2 degree or in between them, or phase matching condition are exactly valid for this particular angle. Otherwise, the pump is scattered into the other possible modes. Because the scattering process is there, we cannot say that every scattering mechanism has a three-wave coupling. This can only be called as the three-wave if the conservation laws should be verified. On increasing the magnetic field, the instability provides some channel for damping of a lower hybrid wave and the growth rate decreases. At the end, I would acknowledge to my mentors and my research group fellows. At the top left is Professor G. Murtaza, and the top middle center is Professor Hassan Isha. He is a ex-vice chancellor. He has served a lot to the physics, plasma physics. And the top rightmost is my right supervisor. He has ever been smiling, as this figure is truly reflecting his personality. He has been a symbol of love, patience, and care to me. Unfortunately, he is not with us, but his memories and his impacts on our personality will rest with me up to the end of my life. And the lower figures are on the bottom left is Dr. A. Rashid, then Dr. Aruj A. Khan, then Dr. Arif Fatma, then Dr. Zahid Mir, and the final completing PhD student is Aisha Rahman. With this, I would pay a lot of thanks as I believe you had shown a lot of patience to listen along, as theoretical statement always is difficult to perceive. Hope the best.
Thank you so much, sir. So, very informative lecture. Now we'll switch toward the question answer sessions. If anybody is having any question, please post on chat. One of the questions, sir, from a student: what does conservation relation indicates?
Please, can you repeat the question?
Yes, sir, sure. What does conservation relation indicates?
Yeah. So we see two laws are as a whole for the plasma system. Momentum is conserved, but for the additional two features should be there. One is the omega naught is equal to omega 1 plus omega. When we multiply H bar on both sides, this will give us the conservation of energy. And the other law is K naught is equal to K1 plus K. When we multiply H bar Planck's constant on both sides, it will provide us the momentum. So it means the momentum and the energy for the set of waves that we are considering should conserve.
One more question is there, sir, by a scholar. Could you please explain the term pendromotive force and its significance?
Yeah, I believe whenever we are talking the coupling of waves, definitely there should be some mechanism, and mathematically, if we see experimentally, we can point three waves towards each other, and definitely something would take place there. But when we are talking theoretically, because theoretical people use some source, mathematical source or mathematical term. So the term that incorporate the coupling effect of the waves is pendromotive force. Simply we say, if we discard all coupling of the three waves, we can say if the pendromotive force is any wave which is sent to the plasma or some oscillating, and it will exert some pressure from on the particle from higher field. As you know, the electromagnetic wave have oscillating field from higher field to the weaker field in this way. But in the case of three-wave interaction, this incorporate the coupling parameters of the sideband and the pump and the lower habit. However, we, as you have seen in our talk, that we couple these modes turn by turn. First, using same term, we couple the sideband and the pump when we are talking to excite a third mode, which is the lower hybrid. And when we are talking to excite or disturb the sideband, then we couple the linear part of dust lower hybrid and the pump. And in all cases, pump should be there.
Thank you very much, sir, for appropriately responding to our questions. There is one more question. I think Professor Prerna Sharma is raising hand.
Yes, yes. Hi, Jamil. I just wanted to know that the dust lower hybrid things is consist of the dispersion is consist of the omega CD and omega Ci, na? Cyclotron frequency of dust and cyclotron frequency of ion. And so, in which part the quantum effects are playing role? And I think
Yeah, sure. So as you would see the dispersion relation, we have V Fermi, and V Fermi is only assigned to the electrons, because no doubt we have dust, ion acoustic wave, but dust is eating electrons, and sometimes it is ejecting electrons. So the effect of electron is there, and we incorporate the quantum features with the electrons. So dust, no doubt. This is because many people have a big question here, how a big size dust should be accommodated within the fluid of electrons. As I pointed in earlier, that no doubt we are not taking dust as a quantum, we are not taking ions as a quantum, but the only electrons are taking, and this quantum effects comes through the Fermi speed. It means all of the quantum effects contribute from the Fermi speed. In this expression, we are denoting it by a V prime.
So mainly your scattered part, sideband part or seed part is affected by this quantum things.
And actually V prime, wherever V prime is, there is a quantum feature of the electrons.
Okay.
So V prime is reflecting all quantum features of electrons.
Okay. Thank you, Jamil. Thank you, ma'am.
Thank you, Prerna ji. I think Professor Deepak Subedi also wants to ask something.
I think no, madam. I'm
No.
just asking for my
Okay.
presentation. Yeah.
Okay, okay. So, any more questions from audience?
Yes, ma'am. One more question is there. SRS is a parametric instability or not?
Yeah, as I told that parametric instability in categories, we defined that there are different categories depending upon the selection of mode. But no, it is usually coming in the category of parametric. So it is better not to say it as a parametric, but simply three-wave interaction. The preferred answer should be it is a three-wave interaction through Raman scattering. But I have seen a lot of literature that whenever there is a three-wave interaction, people are talking about the parametric. So the parametric term has become so wide, it has dominated all over the division, and generally, however, in detail, people do consider the mechanism. So I would say S or S is separate but following the same mechanism. Therefore, I can say it is some extent representing the parametric. But again, I would never, because it would change the all statement if I say yes. So it's not exactly yes, but somehow this term is now overlapping.
So thank you very much, sir, for your graceful presence, as well as this nice responding. And now mic to Sai Shikha for further proceedings. Thanks, Jamil sir.
Okay, thank you. Thank
you,
you.
sir.
I would say thanks to all of you.
Thank you for your stimulating talk. Your comments are especially helpful to those who are doing research in this field. At very basic level, you started your talk, due to which it became very interesting and informative. So again, very big thanks to you, sir. Thank you so much for your talk.
Thanks.
Now, moving ahead with willingness of more learning, I would like to invite scholar Mr. Subhash Chauhan for the introduction of our next speaker, Professor D.P. Subedi ji from Kathmandu University, Nepal. Over to you, sir.
Am I audible?
Yes, sir. Now you are audible.
Thank you, Sai Shikha. Now I would like to introduce Professor Dr. Deepak Prasad Subedi sir. Hello, am I audible?
Yes, sir. Your voice is coming very clear.
We, the member of SS in Physics, welcome you, sir, for joining us in EIPT 2020. Professor Dr. Subedi is currently working as a Director of Research Development and Innovation at Kathmandu University, Nepal. He started his career as a lecturer in Gyanodaya Higher Secondary School upon the completion of his MSc degree from Central Department of Physics, Tribhuvan University. And he joined in 1997, he joined Department of Physics as a lecturer, and he has done his PhD in plasma physics in 1999 from the Department of Physical Electronics, Masaryk University, Czech Republic. After completing his PhD in 2002, he continued his academic position at Kathmandu University as an assistant professor. He has a long 23 or more years of experience as a researcher, and he is a renowned plasma physicist in Nepal. His research interests are plasma diagnosis, plasma surface modification of materials, plasma for ozone generation and water treatment, deposition of thin films by plasma, surface characterization of materials, synthesis and characterization of ZNO thin films, etc. Professor Subedi has published more than 60 research papers in various national and international reputed journals. He has authored 3 books and he has received many awards. Few of them I am sharing with you. National and he won the Mahendra Vidya Bhushan Ka Award and his Royal Highness Crown Prince Youth Science and Technology Award by Royal Nepal Academy of Science and Technology, as well as Education Award by Ministry of Education and Culture. He will talk today about the diagnosis and application of atmospheric pressure plasma. Sir, we are eagerly waiting for listen you, sir, and we had a long memory with you during our EIPT 2015. Now mic is over to you, sir.
Can I share?
Yes, sir. 1 second. Just a minute, sir.
Do you see my slides, please? Okay, sorry.
Yes, sir. Yes, sir.
It is paused yet. Are you seeing my slide, please?
No, sir. 1 minute, sir. I am doing.
You have to make me the co-host, I think. Okay, now it's okay. So, do you see my slide now? Sound, sorry. It was in the bottom. Sorry, I had to. Do you hear me?
Yes, sir.
Yes, sir. We can hear you and we can see your slides as well.
Okay, thank you so much.
Yes, sir.
So I would like to thank the organizer for inviting me to this Emerging Interfaces of Plasma Science and Technology webinar, EIPT 2020. I will be talking on the diagnostics and application of atmospheric pressure or dielectric barrier discharge plasma and its some typical application in plasma agriculture and plasma medicine too. I am here very glad to share that I had the pleasure of attending this program in 2015. Here you can see the photograph just in front of the department. It was a great pleasure when I was there. It was today's program, I think, and we had Professor Raju Khanal also there at the time, and he delivered his lecture yesterday. So it is so nice to meet you all again in this webinar. I hope it would be possible to visit in a physical meeting next time in some day in future too. So the outline of my talk is displayed in the slide that I would briefly introduce the plasma. The speaker just before me also talked some aspects of the plasma, but my focus will be on low temperature plasma produced at atmospheric pressure and its characterization using electrical and optical methods. And another section will cover the applications of plasma for surface modification of polymer and also treatment of crop sheets. And in the next section, I will be discussing on the characterization of the plasma modified materials using various techniques like contact angle and surface energy measurement and AFM, SEM, and stability of the plasma modified surface. So in our laboratory at Kathmandu University, we are working on 3 principal domains of plasma, that is generation of plasma under various conditions, at atmospheric pressure and low pressure using line frequency and high frequency power supplies. And another domain is the diagnostics of plasma using electrical methods and optical methods. And the third important domain is the applications of plasma. We have been working on these aspects, say thin film of deposition, surface modification, water treatment, and plasma medicine and plasma agriculture. The last two domains were quite recently introduced to our laboratory. Plasma medicine introduced in 2013 and plasma agriculture quite recently in 2019. Today, I will be focused on these blocks which are highlighted. Atmospheric pressure DVD using 50 Hz power supply, and electrical and optical methods for characterization, and these three types of application. We know that plasma is also known as the fourth state of matter, which covers more than 99% of the matter, visible matter in the universe. And it is simply defined as the ionized state of matter. As displayed in this slide, you can see that when a solid is heated, it changes into liquid and further heated to gases. And when a gas is sufficiently heated to a high temperature, the atoms in the gas may turn into ions and electrons, forming a plasma. And plasmas exist in nature in quite wide range of parameters described by the electron density and electron temperature. So it ranges from the quite low density, low temperature plasma to high density, high temperature plasma, as in the inertial confinement fusion. And here is you have intergalactic or stellar plasma or ionospheric plasma, which have low density and low temperature. But in today's lecture, I will be focusing on this type of plasma, which are characterized by electron density of the order of 10 to the power 8 to 12 per centimeter cube, and electron temperature from 1 to 10 electron volt. So these are also called low temperature plasma, cold plasma, or industrial plasma. They have found tremendous application in material processing. So we can broadly classify all these plasma into hot plasma and cold plasma. These hot plasmas are characterized by the existence of thermal equilibrium between the species present in the plasma, and their electron density is of the order of 10 to the power 22 per centimeter cube. Degree of ionization is nearly 1. That means whatever there is ionized. The fully ionized plasma or strongly ionized plasma, they are used in nuclear fusion reactors for energy generation, and they are also a constituent of sun and stars. So whereas another type of plasma, which is which we are going to discuss today in this lecture, the cold plasma, they are characterized by the thermal non-equilibrium between the species. That means most of the species, the neutrals and ions, have lower temperature compared to that of electrons. Electrons have temperature of the order of 1 to 10 electron volt, that is around 10 to the power 4 Kelvin, thousands of Kelvin, whereas the neutrals are at near room temperature, about 300 Kelvin. So this is what we call the thermal non-equilibrium. And another major difference with the hot plasma is the electron density. It is about 10 to the power 9 per cm cube. It may vary from 9 to 12 per cm cube. And another fundamental difference between hot plasma and cold plasma is the degree of ionization. It is around 10 to the power minus 4, whereas in hot plasma it is near unity. This means that out of 10,000 particles in this type of plasma, only one electron ion pair may exist. That means even if 0.01% of the particles in this medium are ionized, it may suffice the criteria of this partially ionized plasma. So that's why these are called weakly ionized plasma or partially ionized plasma. They are widely used in material processing. It is because of their nature of thermal equilibrium. It is very important that this graph illustrates the reason why these non-thermal plasma have been quite useful in material processing. You can see that there is a large difference in electron temperature and ion neutral temperature. That means bulk of the plasma is near room temperature, whereas there are few electrons which have sufficient energy to initiate any plasma chemical reaction that is required to carry out the material processing. So this has made it possible that this can be applied for processing of the thermally sensitive materials. So this typical nature of this low temperature plasma have made them immensely useful in material processing, and nowadays the conventional method of material processing are slowly being replaced by plasma. Nearly more than 60% of the world's processing of microprocessors are now based on plasma technology, starting from film deposition to other processing of textile in industries. So studies in 1980s and afterwards have shown that it is possible to generate non-thermal plasma at atmospheric pressure. So generation of this plasma in atmospheric pressure have made them cost effective also. So would you please admit someone is there waiting in the room? It appears in my screen. So when a material is inserted in plasma, it interacts with the material, and the interaction of the plasma and the solid material is illustrated in this slide. So the interaction leads to the changes in chemical and physical properties of the material, and leading to the modification of the surface, which may result in chemical selectivity, improvement in mechanical hardness, enhancement in electrical conductivity, and altering the optical properties. That's why low temperature plasma has been used in tailoring the surface properties of materials, especially thin film deposition in industries and also in fundamental vessels. So based on these properties of the plasma, they have found application in environmental aspects. So for the controlling of gaseous pollution, water treatment, air pollution, fuel production from CO2, and similarly in biology for cancer treatment, wound healing, sterilization, and gene transfer, and similarly in fuel synthesis, plasma assisted combustion, ignition of fuels, and the most importantly for material processing, say surface treatment, which is the main objective of today's presentation, and surface treatment of materials. I will be focused on this application. So the principally this low temperature plasma reaction has been employed in solving the problem related to environment, biology, energy, and materials. So these plasmas, which have been practically applied in industry, were originally observed in the low pressure gaseous discharge system as early as 1879, when Sir William Crookes named it as radiant matter, when a gas in low pressure gas discharge, low pressure system is applied with high voltage power supply of a few tens of kilovolt, it dissociates and a radiant glow is observed with different designs. And modern plasma reactors are the modified version of this system, which is now a textbook material for all elementary physics in high schools also, the glow discharge plasma. The modern reactors are modified in the sense that the diameter of the tube is increased and the distance between these electrodes is reduced, and this positive glow will cover almost the entire region between the two electrodes, and that is what we call modern plasma reactors. An American chemist, Irving Langmuir, in 1927 described this state of matter as plasma. So they have found this plasma generated at low pressure have found very wide application in thin film processing, and they are well understood and are used extensively nowadays. But the problem with this type of plasma is that they are generated at low pressure, means they need a vacuum chamber, vacuum pump, and pressure gauge, which results a huge cost of installation. So there have been some comparison with this plasma, low pressure plasma and atmospheric pressure plasma regarding their application and cost of operation and cost of material processing. So if we consider the cost of material processing using low pressure plasma, it's about $1,000 per centimeter square of the material processed. Whereas in atmospheric pressure, it is about $0.05 per meter square. So this is a huge difference in the processing cost. That's why there has been growing interest in generating plasma at atmospheric pressure, thereby producing cost-effective plasma. And we in our laboratory at Kathmandu University are working in designing and testing plasma at atmospheric pressure, which can be applied for material processing. So our focus is on generating cost-effective plasma. So the early works in this direction are generating plasma at atmospheric pressure, homogeneous plasma at atmospheric pressure. It started as early as 1980s when a group of researchers led by Okazaki developed an atmospheric pressure diffuse barrier discharge, which they designed as atmospheric pressure glow discharge APGD. After this, there have been a lot of work in this area in different laboratories around the world to generate stable and homogeneous discharge at atmospheric pressure. So here is an example of atmospheric pressure dielectric barrier discharge applied for treatment of textile fiber. So the major reason for attraction in this type of plasma is the reduced cost of installation and operation, and their ease of operation, and the possibility of continuous treatment. A major advantage is this possibility of continuous treatment because they are operated at atmospheric pressure. In low pressure, we should have batch process, and we take it out the sample from the chamber and load another sample and pump down the reactor and discharge again. So it is quite time consuming compared to this atmospheric pressure discharges, where we can have around hundreds of meters of materials passing through the discharge per minute. So this offers one great advantage over atmospheric pressure, low pressure plasmas. So the question arises, how can we generate this type of plasma in atmospheric pressure? So it has been suggested that there are some ways to prevent the formation of an arc and producing glow-like discharge in atmospheric pressure if we use inert gases to lower the breakdown voltage, use high frequency power sources, and insert dielectric barriers between the electrodes, and control the gas like say inert gases like argon, helium, or neon. And by restructuring and designing the proper set of electrons, the homogeneous plasma can be obtained even at atmospheric pressure. So here is a system, a very simplified system of this atmospheric pressure dielectric barrier discharge system. What we need is the two metal electrodes and barrier material. It can be single barrier as well as double barrier. We can have only one or two barriers, and kilohertz range of power supply for better formation of the discharge. But to make it even more cost effective, we tried it line frequency. That was one major advantage, that it can be operated for longer time compared to the high frequency discharges. And one important feature of this atmospheric pressure discharge is that it may be in it may appear in a filamentary mode. There may be numerous filaments between the electrodes, and the major challenge in the present or convert this filamentary mode to glow mode or uniform discharge mode. So researchers working in this atmospheric pressure discharge are focusing how can we convert this filamentary mode of discharge into glow mode, which is more uniform, and the treatment carried out in discharge may be homogeneous. So there have been reports on various types of this dielectric barrier discharge, on the parallel mode, coaxial electrode mode, coplanar mode, and planar mode, especially designed to serve for different purposes. These basic studies or diagnostics refers to this parallel electrode mode. This is simply, it looks like a capacitor, two parallel electrodes, and there is a barrier between them, and widely used in material processing. And this coaxial in cylindrical mode is preferred for ozone generation and pollution control. And this coplanar mode, also known as surface barrier discharge, is used in biomedicine and UV lamp and plasma displays. And this type of planar electrode mode is used in aerodynamics and microwave absorption and plasma display. So in our laboratory, we have generated and tested these several types of atmospheric pressure discharge. Parallel plate electrode with cylindrical electrodes, and parallel plate disc electrodes, and disc and hemispherical electrode, and then simple parallel plate electrodes use surface discharge and discharge at, with transparent electrode, and atmospheric pressure plasma jet, where the jet is coming out of the electrode system, making it quite suitable for treatment of the living tissues in plasma medicine. So far, we have been working in these types of atmospheric pressure discharges in our laboratory. So I would like to describe some experimental results regarding the treatment of polymer and some crop seeds that have been investigated for their surface properties. So this is the flow chart of our experiment. We first generate DVD in atmospheric pressure. It is characterized by optical and electrical methods. And the plasma is now employed for surface treatment of polymer gem sheet. And these surface treated materials are characterized by these diagnostic tools, characterization tools. So this was the system used for generation of atmospheric pressure plasma. Here you can see the discharge generated in atmospheric pressure. The inter-electrode distance can be varied from 2 to 5 millimeter, and it uses a step of transformer that can supply a power supply up to 18 kV RMS. Here we have copper electrodes separated by a polycarbonate dielectric material, and the electrode size are 5 by 3 and with a thickness of 1 centimeter. So this is our experimental setup. Here you can see the discharge between this upper electrode and barrier. We have used a single barrier system. The barrier is placed in the bottom electrode, and the current is limited by using a ballast which ranges from 5 to 20 megaohm. And the current of the discharge is measured by using this shunt resistor, where the potential across this is measured and divided by the resistance to obtain current. And we have here a high voltage probe. There is an optical emission spectrometer to analyze the discharge and the plasma species. So this is the first part of the presentation. I will devote on plasma diagnostics. Here you can see the methods employed in general plasma diagnostic any laboratory. Usually we use basically these methods are electrical and optical. In electrical we use Langmuir single probe, double probe, or in-sheet probes. And in optical methods, we may use optical emission spectroscopy, optical absorption spectroscopy, or laser-induced fluorescent spectroscopy. For present work, we had used current voltage characteristics, maybe IV characteristics, and optical emission spectroscopy to determine the electron density and electron temperature in the discharge, and to confirm that it is low temperature plasma. So we used this TDS 2002 Tektronix for the electrical characterization. Here you can see the typical IV characteristics of dielectric barrier discharge. In order to obtain the electron density, we had used power balance method, where we need to find out the power consumed by the discharge in per cycle of the discharge. So by plotting this QV Lishaz's figure, we obtain the power and hence the energy consumed by the DVD system. And this method was used, this equation was employed to obtain the density of electrons in the discharge. Here PAV represents the average power delivered to the plasma by the power supply. A is the electrode area, VV is the bomb velocity, and E is the energy lost by collision, energy lost by the electron through collision. And using this power balance equation, we obtain that the electron density is in the range of 10 to the power, on the order of 10 to the power 11 per centimeter cube, which fairly agrees with the values of electron density reported in the literature, and it falls in the glow discharge type of plasma, low density plasma. Another method that we employed was the optical emission spectroscopy for the characterization of the discharge. We used this ocean optics emission spectrometer, which can scan the discharge from 200 to 1100 nanometer, and it has an optical resolution of 0.1 nanometer, and indication time ranges from 1 millisecond to 65 seconds. So here you can see a typical optical emission spectra of a dielectric barrier discharge generated at atmospheric pressure. It is mostly dominated by nitrogen lines and argon lines. Out of these several lines obtained in the discharge, we had selected 4 lines of nitrogen second and nitrogen third as shown in this table. And by measuring the ratio of intensities of these different lines, we were able to determine the electron density. This is widely known as the line intensity ratio methods. Here you can see that this ratio R1 and R2 will yield as a function of this RKTE will yield a line, okay, this type of line, and the slope of this line will help us to determine the electron temperature by inserting the values of these parameters of this transition probability, and then statistical weight, and the intensity this for the 4 lines as shown in this table obtained from the niche database. We found that the electron temperature is around 1 eV, 0.97 electron volt for this discharge generated in the barrier mode. So it safely falls within the range of the thermal non-equilibrium plasma. And it is also possible to obtain the electron density by analyzing the spectral intensity of the discharge using this equation by substituting the values of electron temperature obtained in the previous calculation KTE in this equation and inserting the values of lambda and A2 A1 and G2 G1 in this equation. We were able to determine the electron density in the discharge, and it falls around 10 to the power 11 per centimeter cube. So TE 1 eV and electron density NE around of the order of 10 to the power 11 per centimeter cube. So this way we have characterized the dielectric barrier discharge and atmospheric pressure using emission spectroscopy. I must mention here that for low pressure discharge, there are a lot of methods using say Langmuir probe and double probe, single probe, emission probe, and other methods. But for atmospheric pressure, there is a problem that we cannot use Langmuir probe efficiently because of the smaller distance between the electrodes. That electrode gap may be less than 5 mm, and when we insert the probe between the electrodes, there may be discharge with the probe itself, and this does not fulfill the requirement of the probe method, that the probe itself must not influence the discharge. This is one of the most important criteria for the probe method, and that is one reason. And another reason of using difficulty of using this type of probe is the shorter mean-free path in atmospheric pressure. That will not satisfy the criteria required for the probe model that has been used in low pressure discharge. That's why there has been a lot of work in finding out some satisfactory method to characterize atmospheric pressure discharge. And since this optical method is non-invasive, it is quite attractive method for the characterization of the discharge. So the second part of my presentation is focused on the surface modification of polymers. We know that polymers are widely used these days because of their very excellent methods. And there have been a lot of techniques to modify the surface of polymers, say by using thermal treatment, electrical method, and mechanical method, and wet chemical treatment. But these conventional methods are labeled with their poor reproducibility and poor controllability and non-uniformity of treatment. Would you please allow there is someone waiting in the room and it falls just inside my slide, so it is difficult to see me the content. Hello, madam.
Yes, sure, sir.
Yeah.
One more. Yeah, another co-host will manage it. Yes, sir.
This message just falls and covers my slide here. Please.
Yes, sir. You just continue. Another co-host will handle this.
So can I admit them myself? It would be easier.
Okay, fine, sir, fine.
So these methods are leveled with this limitation. That's why plasma has been recommended as a suitable method for treating the surfaces because they are dry and low temperature system, and because of the ease of operation, they are environmentally benign because the conventional method like this wet chemical treatment use a lot of toxic liquid that is used for etching or deposition of the film, and after the processing they are dumped in the river, so that is environmentally not safe. That's why the plasma is a dry process and it does not use this toxic liquid. That's why they are environmentally benign, and they can induce physical and chemical surface changes through several processes. They are controllable and reproducible. That's why plasma offers a better solution for surface treatment compared to the conventional methods. And here is a comparative analysis of the plasma with other methods, say UV activation, ion beam, corona, and hydrogel. You can see that for most of the properties, say wettability, dry lubricity, wet lubricity, hemocompatibility, reduction of bacterial adherence, drug delivery, reduction of protein absorption, immobilization of the biomolecules, improvement of cell adhesion, improvement of tissue integration, anti-fogging, improved adhesion, improved metal hardness, and reduction of metal corrosion. So if we compare the properties incorporated by plasma, it complies in most of the properties with limited only 2 and no in 1 in most of the processes. It complies. That means that it is superior to other methods based on this comparison. That's why this low temperature plasma are gaining popularity in industrial processing these days. So our main objective is to obtain a hydrophilic surface which are characterized by good wettability and better adhesion. So this method is very ready and quite quick test for assessing the effect of plasma on polymer or any other materials. Measuring the angle of contact with the treated surface will give immediate inference about the effect of plasma on the surface. So usually polymers are characterized with low surface energy, rendering them to be hydrophobic materials. And in order to widen their application, say in biomedicine or in industrial processing for composite materials, or for dyeing or printing or coloring, it is desirable to have a hydrophilic surface. So what we do in our lab is we just insert the material in plasma for a few seconds and characterize it by measuring its angle of contact with 2 or 3 different test liquids. And obtain the surface energy that has been altered by the treatment of plasma. In this present talk, I will share some of the results regarding the surface treatment of polyethylene terephthalate using 50 Hz discharge and air and argon environment, and electrode spacing 3.5 cm, and treatment time varying from 5 to 60 seconds. The treatment variables were time, gas supply, and type of the polymer, and method of characterization were contact angle measurement, SEM, AFM, and this equation was used to determine the surface energy of the sample after treatment, and not only surface energy but its polar and dispersion component were determined. And this table shows you the liquids used as a test liquid: water, glycerol, and dihydromethane, and it enables us to obtain this gamma S LW, gamma S minus and gamma S plus. This is polar and dispersion part of the surface energy. And we see that before treatment, the angle of contact with the PET is 76 degree, while after treatment it reduces to 43 degree, and in argon discharge 32, and in air discharge it is 43. And it also shows that there is a good correlation with the surface roughness. As SEM, I don't know whether it is clearly visible to you or not, but there is change in surface roughness in these images, SEM images. Maybe this AFM images will be more evident to see the change. You can see that there is a significant improvement in surface roughness after the treatment, and this reduction in angle of contact can be correlated with the increased roughness of surface. And other reports have also shown that this change in surface property is not only physical, but there is a physico-chemical process. In chemical process, if we analyze using, say, XPS or FTIR, it is found that functional groups like hydroxyl or carboxyl or amine type of groups are incorporated in the polymer surface after the treatment. So this change in surface property may be partly due to chemical and partly due to physical. And for chemical analysis, we can use XPS or FTIR or other chemical analysis methods, whereas for physical, we have used this SEM and AFM. And you can see the effect of treatment time on the PET here. In fact, we have also studied other polymers, which I have excluded in today's presentation because it is not possible to cover all these results in this 1 hour talk. So I have used only PET. It shows that compared to polypropylene and high density polyethylene, the reduction in angle of contact is significant in this PET because it contains oxygen in its parent chain. This polypropylene and high density polyethylene does not have oxygen in their parent chain. So it is difficult to hydrophilize them compared to this PET. And this is in air discharge and this is in argon discharge. So our analysis also showed that it is the polar component that is responsible for the increment in the surface energy. So before the treatment in plasma, the dispersion component covered about 96% of the total surface energy, while 3.16% was the polar component. But after the treatment, polar component increased to 18.1%, while there was a reduction in dispersive component. So this gamma P is responsible for the increased surface energy of the polymer in treatment. And these polar moieties, which interact well with water drop, because water is a polar liquid, is well reflected by the reduction in angle of contact with water. But it should be mentioned here that the plasma modified surface is not stable for a long time. This hydrophilicity obtained after plasma treatment will not be stable for longer time. We have studied what parameters are responsible for controlling this hydrophobic recovery of the plasma modified surface. Reports have shown that after several hours of treatment, the plasma modified surface may regain its original hydrophobicity. So this time, tau shown is called the relaxation time. The increased surface energy of the polymer is due to the incorporated functional group on the surface, and this increased surface energy may lead the surface to be unstable, and it tries to go to the bulk, thereby gaining stability after certain time tau. That is what we call the relaxation time. And in our study, we checked whether there is some way to reduce or elongate this time tau and make the surface longer, stable for longer time. What we did is that we stored the sample in room temperature and another sample in low temperature in fridge, and we found that there is some clear difference between the hydrophobic recovery. So sample stored in fridge in -10°C recovered the hydrophobicity chloride more slowly compared to the sample stored in room temperature. So this may be a solution to retain property incorporated by plasma for longer time. So this graph shows the sample treated at 50 Hz, and this one shows sample treated for 30 kHz plasma. And it is even interesting to see that if we treat the sample in 30 kHz power supply, the effect of storing temperature is even more prominent. So we have, I will very briefly display some of the application we have done. We have employed in this modifying the properties of the polymer. This is untreated cotton sample, where you can see that it is quite difficult to color this material, and after treatment in discharge, the ink is absorbed by this material, demonstrating that it is possible to paint or color or dye the material. So this reduction in angle of contact was achieved by the treatment in atmospheric pressure dielectric barrier discharge. And here is another application. We employed this discharge to improve the adhesion of this aloe vera gel on various polymeric materials: polycarbonate, polypropylene, polyethylene, polyethylene terephthalate. Here you can see that coated material, and flow test carried out in this sample shows that the treatment in plasma improved the adhesion of this aloe vera gel, which is a very good biomedical material, to this polymer. Without, if the sample material is coated without plasma treatment, the aloe vera coating was delaminated after a few hours of test in flow. But plasma treated sample could retain the aloe vera coating for longer time. So recently, I just want to share some of the recent results in application of plasma for enhancement of the germination rate in radish seed, and also for the growth of seedling of radish treatment in atmospheric pressure discharge. We used this atmospheric pressure DVD in air for treatment of seed. We had used 250 seeds in each tray, and treatment time was 1 to 5 minutes. And you can see that there is a remarkable difference between the germination rate of the radish seed before and after treatment. And we also compared their seedling with root and shoot growth for control 1 minute, 2 minutes, and 3 minutes. And our preliminary results have significant effect. And we are, since this is a recently induced field, we need to go up to the crop yield also. So that's why I just shared some of the preliminary results in this area. Now I would like to summarize my today's presentation. That we have been able to generate atmospheric pressure in dielectric barrier discharge mode using 50 Hz power supply, and electron density and temperature were measured using optical and electrode methods. And the discharge has been successfully employed for surface treatment and treatment of crop seeds. And our preliminary results have indicated that there is a significant enhancement in germination rate of the seeds and also the growth rate of the seedlings. I would like to thank you all for your patience. Before that, I would like to acknowledge our research collaborator from University of Poland, Professor Andrzej Huczko and his research group for helping us in the characterization of the materials. I would also like to thank Professor C.S. Wong and from University of Malaya for his support in our research work on plasma generation and characterization. And at the end, I would also like to thank our research group, plasma research group at Kathmandu University. So thank you very much for your attention.
Thank you very much, sir. Now we will switch towards the question answer session. Very first question, which is asked by Dr. Asif Javed ji. What is the meaning of dry and low temperature?
What is the meaning of ion?
What is the dry and low temperature? Dry and low temperature.
Okay, it is a low temperature in the sense that the temperature of this bulk of the temperature of the plasma falls in room temperature around 300 Kelvin. Compared to fusion plasma, it is called low temperature because in fusion plasma, the temperature may range from 10⁷ to 8 Kelvin. So low temperature means that it is low compared to fusion plasma. It is also called cold plasma. And dry means that it does not use any liquids for processing.
Thank you, sir, for the reply. And next question is from Rakesh, sir. Why is the breakdown voltage in helium plasma lower than that of other noble gases used, although the ionization energy of helium is highest?
It is explained by the Paschen curve. We need to, it is the property of the gas that they have different dielectric strength. So when discharge takes place is determined by the property of the gas. So we need to see its Paschen curve because the breakdown of a gas is not only a function of the inter-electrode distance, but it depends on the pressure also. So if we check the breakdown voltage as a function of product of P and D, we will know why a particular gas has a lower breakdown voltage and why has a higher breakdown voltage.
And next question is, what is the method of contact angle measurement? This question is by Dr. Priya Jain.
Okay, it is, we have used sessile drop method. Can I show the slide here?
Sure, sir, sure.
Okay, I can show the method that we have used is incorporate that sessile drop method. What we do is we just set a drop of 4 to 6 microliter in volume, and after 2 minutes after setting the drop, its image is captured, and there is a software in the goniometer. It is called contact angle goniometer, which draws the tangent in this 3-phase boundary, liquid, solid, and gas phase boundary, and this tangent drawn inside the liquid, this angle measured inside the liquid gives the angle of contact. It is called contact angle goniometer. We are using Reinhardt system for this.
One more question is there, sir. It is by Sanjay Goyal ji. Your material depends on pH value.
Your material? Sorry, once again.
Depends on, your material depends on pH value.
depends on industrial
pH
heat or
value.
sorry,
pH value.
I think
pH value.
yeah, he is
Okay,
asking
pH
that
value.
your choice of material, whether it depends on pH value.
You mean pH value?
Yes, sir, pH value.
Okay, so that's why we have used for water, we use doubly distilled water. So other liquid were also standard laboratory liquids, because it may depend on pH also. The angle of contact is a function of the surface tension of the liquid, and it in fact depends on the pH value. That's why we have used doubly distilled water for the characterization with normal water property. I think I could get the question correctly or not?
Yes, sir. Definitely.
Okay, madam.
I would like to ask any another question from audience. If anybody else want to ask. Okay, fine. Thank you so much, sir. Please accept our sincere appreciation and big thanks for your outstanding presentation you delivered. It was very interesting to hear about your memories with EIPT-2015. The slides you shows gives us a close look at low temperature plasma. Once again, thank you so much for sharing your precious time and experiences with us. Thank you so much, sir.
Yeah, I would also like to thank the organizer for inviting me and giving this wonderful time to share my experience with so many research workers around this region. So thank you so much, especially Madam Dubey, for inviting me.
Thank you, sir.
Okay.
Thank you,
very
sir.
much.
Okay. Thank you.
Now, moving ahead, if you fail, never give up, because fail means first attempt in learning. And it is not the end. Effort never dies. And if you get no as answer, remember no means next opportunity. Now, in the process of sharing and learning, it's time to invite our next speaker. Without taking much time, I will invite on mic Dr. Apurva Mule ma'am for introduction of next speaker, Professor G.R. Sinha from MII.
हाँ, अपूर्वा, आपकी आवाज नहीं आ रही है.
Hello. Am I audible, ma'am?
Yeah.
Ma'am, am I audible?
Yes. Now you are audible. Carry on.
Ji, ma'am. Very good afternoon to all. Myself, Dr. Apurva Mule. First of all, I welcome to Professor Sinha at the very stage of EIPT 2020. Dr. Sinha is adjunct professor at International Institute of Information Technology, Bangalore, and currently deputed as professor at Myanmar Institute of Information Technology. He obtained his engineering degree and MTech degree with gold medal from National Institute of Technology, Raipur. He received his PhD in electronics and telecommunication engineering from Chhattisgarh. He is a visiting professor in Sri Lanka Logical Campus, Colombo for 1 year, 2019-20. He has published 250 research papers, book chapters, books at international level that includes biometrics published by Ville India and many more. He is currently editing 6 more books on biomedical signals, brain and behavior computing, modern sensors and data duplication elsewhere, IOP, CRC Press. He is active reviewer and editorial member of more than 12 reputed international journals in his research areas. He has been Dean of Faculty and Executive Council member of CSVTU and currently a member of Senate of MIIT. Dr. Sinha has been delivered ACM lectures in the field of DSP since 2017 across the world. He is a recipient of many awards and recognitions like TCS Award 2014, IST National Award 2013, ISTE New Delhi Emerging Chhattisgarh Award 2013, Engineering of the Year Award 2011, Young Engineer Award 2008, Young Scientist Award 2005, and many more. He has delivered more than 50 keynotes or invited talks and chaired many technical sessions in international conferences across the world, such as Singapore, Myanmar, Sri Lanka, Bangalore, Mumbai, Trivandrum, and etc. His session on deep learning biometrics was included in IEEE International Conference on Imaging Processing 2017. He is a consultant of various skill development initiatives of NSD, Government of India. He is regular referee of project grants under DST-EMR scheme and several other schemes of Government of India. He received few important consultancy supports as grants and travel support. Sir, now I would to invite you to present your talk.
All right, thank you so much, Apurva, for a nice introduction. At the outset, good afternoon to everyone. Namaste to everyone. It's my immense pleasure to be part of your this wonderful program. In fact, last 4 or 5 months, I have been receiving a number of lecture invitations, and more than 14-15 lectures I have delivered. But I was wondering that how did I receive invitation from the Department of Physics? Then, I mean, there are 2 reasons why I can't say no to this invitation. One is I believe that what the technology, electronics engineering, computer technology, all are the outcome of physics only. That is my understanding. Physics is mother of everything that what we are doing today, what we are doing in the technology in engineering. I think physics is mother. So I could not say no. And bigger reason, even bigger reason is Dr. Swati madam, I can never say no to her. So therefore I happily agreed, given consent for this lecture. So thank you so much again, once again for this invitation. Now I will share my screen and we'll go ahead with the lecture. I hope these slides are visible to all of you.
Yes, sir.
Okay, thank you so much. So I once again very humbly request all of you to kindly get muted so that there is no disturbance in the lecture. So I think the topic of my lecture is cognitive science, physics, and its capabilities. Cognitive science, physics, and its capabilities. The cognitive science is the area where I have been currently working with my collaborators and the research scholars. The collaborators include from more than 3 to 4 countries with whom we have been working together in this important area. And therefore, I believe that cognitive science has a major role that gets originated from physics. So therefore, the title is Cognitive Science, Physics, and its Capabilities. What are the capabilities of cognitive science area? So the outline of talk will be cognitive science. I will be talking on cognitive science, introduction and motivation. Then I will be attempting to highlight current research trends. I won't give much time to, in discussing current research trends. Then research approach, what research approach we are using and other researchers have been using in order to carry out, in order to investigate the capabilities of cognitive science physics. And lastly, issues and challenges. Because in my understanding, I believe that in all such activities, such programs, I must congratulate the department, Dr. Dubey, for choosing a very, very appropriate topic. That interface is very much needed. The collaborative work and the interface work is very much needed in the current time. So in these type of activities and the programs and lectures, in my understanding, we must conclude by certain issues and challenges, those challenges that could be taken up by young researchers as their future research direction. So as you can see one picture here, an interesting picture here that that shows one the structure of brain, and the signals are emitted from human brain, and those signals are interfaced or received by the computer. So this is what is called as brain computer interface. And here in brain computer interface, the role of this brain signal is very important, and there physics comes into picture. Because when we think that the signals are emitted, signals are generated from human brain, what are those signals? Those signals are actually, the physics of human brain. And those physics, that physics of human brain gets intercepted, gets interpreted by the computer, and there are different applications of these areas. So let's move ahead. I mean, I just want to utilize this because this is a very important area. In recent years, last 2-3 years, I have edited and authored these relevant books which are on these similar topics only, that is on cognitive science. I'm still, currently editing 5 to 6 more books on similar areas. So those who are touching in some similar areas of these things, you are kindly invited to contribute chapter. So let's begin with straight away. Let's begin with the first part of the lecture, that is introduction and motivation. And let me try to correlate what is cognitive science and what is cognitive science physics. So actually cognitive science is these days a general term, an interdisciplinary term. And cognitive science actually is the study of mind, or you can say study of brain, because brain is different from mind. So it studies mind and what are the processes, what are the activities, what are the emotions in which the human brain is engaged. Those activities, those processes are interpreted by the science, by the area called as cognitive science. So it includes the intelligence, it includes behavioral knowledge, the behavior analysis, the intelligence of human brain, how much intelligence it has, how much knowledge it has acquired. All these things can be studied in this area. So mental faculties include cognitive science, as I told you, is an interdisciplinary area, and therefore it includes language, perception, memory, attention, reasoning, emotion, etc., etc. And cognitive science includes the cognition in humans, animals, and machines. But in my lecture, I'll be focusing only on the human cognitive ability or human cognitive science. So cognitive science, as we can see in this slide, it includes philosophy, linguistics, anthropology, neuroscience, artificial intelligence, psychology. These are the major domains which are covered in cognitive science. And as you can see here, the education means study of how people learn. How does a human being learn? What is human learning ability? What different types of learning and how learning affects human brain? So that kind of study is included in this domain. Philosophy, study of knowledge, reality, existence. Artificial intelligence, because these days computers understand like machines. Computer understands like human brain. So what is the role of AI? Then psychology, which includes study of human behavior and the mind. Neuroscience, that is study of entire nervous system. Linguistics, study of language. Anthropology, general study of human society and culture. So these are cognitive science. As I told you, is not a single term, is not a single research area, but it is an interdisciplinary which includes many major research domains, and these are the research domains. So when we discuss about cognitive science, we must not forget about brain computing or brain computer interface. Because when we are interested to explore the capabilities of human brain, then what is important is brain has to be interfaced with the computer. Then only the brain physics, the brain physical activities could be read and could be interpreted. And therefore, this is the area called as brain computer interface, which is actually also called as neural computer interface, mind machine interface, direct neural interface, brain machine interface or connectivity. These are different names. And this is directed towards researching, mapping, assisting, augmenting, repairing human cognitive and sensor motory functions. Because in brain, we believe, and the study suggests, and it's fact now, the human brain is a nervous system. It has billions of neurons, and those cells, those neurons are connected in certain manner. And each neuron, now I'm talking about physics, each neuron contributes something in the brain activity. And that is the electrical potential when the neuron gets excited. Whenever we think, we cry, we smile, we are happy, we are sad, we are upset. In all those different conditions, the neurons get excited in different manner. And accordingly, there is a spike, there is an electrical potential which is generated. And that is called as brain signal. I will discuss about brain signal to some more detail in coming slides. So there are now biomedical devices which are used to capture the brain signal. And as far as the brain signal is concerned, there are different modalities. The modality which is very popular, all of you must have heard about, is EEG, that is electroencephalography. Wherever there is some abnormality, there is some mental disorder in anyone's human brain, then the doctors suggest go for EEG recording, that is electroencephalography. Then comes electrocardiography, that is also correlated. Then magnetoencephalography, MEG, then EMG. These are the major modalities. Modalities means the types of signals which are captured, which are acquired from brain signal. Why do we acquire? We'll discuss later. But what I'm trying to make a point here is these are the main signals which are recorded from the brain as the brain signals. And EEG test is used to find the problems related to electrical activities of brain. Whatever we do, whatever human brain does, there is some electrical activity that goes inside, and that normal electrical activity in the brain makes recognizable pattern. Through an EEG, doctors can look for abnormality. What is the point here is there is a normal human brain and there is abnormality, that is abnormal human brain. So in both the cases, the signals generated, the signals acquired will be different. This is the motivation that why this area is needed, why cognitive science physics study is needed. I'm not going to read the entire slide, but what is the major point which is being highlighted that I will tell you. This scenario is globally present, but I have included the scenario of India only. And if you read the third, fourth lines, third one, the sum of total years of life lost and years lived with disability. Disability means either anxiety disorder, bipolar disorder, and conduct disorder, autism. There are different depression and other things are there inside human brain. So those things with which the person lives, it has doubled from 1990 to 2017 from 2.5% to 4.7%. Now you see the next line, anxiety, the total of 44.9 million, that is around 45 million, which is 4.5 crore people suffered from these mental or any type of mental disorder, that is accounted for loss of that is 1 in 5 years. So this is the scenario. As per WHO, 7.5% of Indian population suffers with some that is mental disorder, and the mental illness constitute 1/6 of health related problems. Almost 15% of people suffer with mental disorder. Can the diagnosis be augmented? That is the study which is called as cognitive science research. So the demography is big in India. So to cater it, the mental health professionals and the expertise are not that much. And therefore, the research is very much needed. Yes, is there any problem?
No.
Okay.
Sir, please continue.
There is the latest finding, and the latest finding suggests that this study was carried in the in a research, and you can read this that line in the image. Human brains replay waking experiences during sleep. So whatever we do in the whole day, those activities, those memory gets replayed when we are asleep. It means something is going on inside. Something is always there inside the human brain. Some activities are going on. I think some people are raising hand. I think I can take the questions at the end of session only. So current research trends, as I told you that I will not be discussing much on current research trends, but I can only tell you what are the major research trends where this type of research is going on. The application of EEG and BCI includes disease prediction like sleep disorder, epilepsy, tumor detection, Alzheimer's disease, attention deficit, emotion assessment and cognitive assessment. How much is the learning capability? In one of our research, we found that female have more learning capability, have more memorization capability as compared to male. Similarly, the age group, if you go towards children group, that is the young group, you will find the memory capability, the cognitive abilities more as compared to the adult and the higher age group. So these are the findings which are established by the research on the basis of EEG signal. So neurorehabilitation, where you can treat some person. Robotics are having nowadays a lot of emotions and the human brain like capabilities robotics are having. So those are the areas where current research is going on. And these are the major domains where the cognitive research continues: brain-computer interface, EEG and machine learning, cognitive assessment, and then optimization techniques. That is still the processes, the methods are getting improved in order to improve the result of cognitive ability of human brain. So I have included current research papers. I'm not going to read all these things, and these are from very, very reputed journals like IEEE Transactions, high quality elsewhere journals. What I can say is, if you focus on research on BCI, the researchers are doing on research in the intracortical recording, neural decoding of human brain, and then cognition and learning capability of human brain, signal processing for motor imagery. Motor imagery means when I move my hand, when I blink my eyes, when I speak something, when I smell something, when I move any part of my body, it is always controlled with human brain. Something we recognize, our cognitive ability says that move this, blink your eyes, see this, and accordingly we have the movement. So that is the motor imagery. There are the research in this area like cerebral anatomy analysis, then EEG biometric person recognition, concentration estimation, how much concentration is there, evaluation of different EEG acquisition systems, brain wave understanding. So these are the research areas or research work which are going on in these areas. EEG artifact removal, then automatic identification and removal of ocular artifacts. Artifact, what is artifact? I'll describe in the next slide. It is because of the different movements. Then stimuli and feature extraction. So these are the more research paper on this area. Then there are research on cognitive assessment. If you read the title, that mental fatigue assessment, when we are mentally tired, how do we get that? What happens inside the brain when we are tired? How can we assess? Can we assess it? So there are research in these areas. And I can tell you it's not like engineering and technology. It's a physics, because we get the signals as the waves. What those waves are, I will explain very soon. And those waves are analyzed using any signal processing method. That's all. It becomes cognitive ability assessment. Automatic stress detection in working environment, how much stress we undergo in certain working environment. Does the stress level change from environment to environment? I mean, from education sector to IT sector, does the stress level change? All these are part of the cognitive research. Then there are papers in this area, and the last one is machine learning and EEG. There are enormous amount of research in EEG and machine learning, because EEG is the modality, and we have to understand EEG, we have to apply some machine learning methods to train the signal, to understand the signal, to interpret the signal. So therefore training process goes, training process is performed. And how do we do training? All of us nowadays know that suitable machine learning or artificial intelligence based method is applied in order to train the signal, and we get certain conclusion. So these are research on machine learning and EEG. Then research optimization. We are doing some research in certain areas of cognitive assessment, but as far as the research is concerned, there is always scope for the optimization, that is the improvement of performance. So these are the research on optimization. And then what are the problems out of these research areas? The problems are, the major problems are, the brain signal is non-stationary. Now I'm coming to the physics part. The brain signal which we get, I will also show you how the brain signals look like. What do we understand by brain signals? I will explain. But the brain signals are non-stationary. They are not stationary. And the signals which are non-stationary, it's very difficult to understand. So that's a research problem. That's a big challenge. And huge dimension. You extract number of signals. When you go for EEG recording, there is a special set of electrodes. I have included in my slide. So cognitive assessment is a subjective area. From one person to other person, you get the same signal. The understanding may slightly differ. So it's a purely subjective area. There is no general purpose theory that can be applied for one EEG, and then that EEG analysis can be applied to everyone. That's very difficult. Selecting a proper channel. When you put electrodes over your head, that is your scalp, how many channels, how many nodes you have to put, how many electrodes you have to put, that is very important. How many electrodes will be providing us optimal signal? That is another research problem. So these are the difficulties. And then feature extraction and feature selection. When we acquire the brain signal as EEG signal, how many features are needed? And if I get, for example, 20 features, out of 20 features, which are the appropriate features that will help us in order to establish or in order to reach to certain conclusion that is supported by substantial result. So research approach. I will go to research approach now. This is the major part. And then one slide, last slide will be on issues and challenges. So I'll be giving more time only on research approach. I spoke about the introduction, what the cognitive science is, what does motivate us to do some research, to study something in cognitive science area. And then I spoke about what are the emerging trends, what are the current research trends in which the researchers have been doing research work in last decade for a few years, around 10 years or more. So you can see interesting diagram here. It's a brain computer interface. And if you look at the bottom image, there we can see that the EEG is recorded, then it goes to pre-processing, because when we get EEG signal, that's the raw signal, and the raw signal cannot be analyzed. So it's going to pre-processing, then we extract the features. See, these days it's not a matter of physics, computer, chemistry, or mathematics. Feature extraction is an easy task. When I buy a smartphone, I record my fingerprint. So does it record my image? No. It extracts the suitable features, and those features are stored inside the template database. Next time I put my fingerprint, I'm authenticated by matching my values, matching my parameters, matching my statistical features. So those features I'm talking about. So feature extraction takes place, and after that classification. Classification means what is the status of brain, whether it is normal brain or abnormal brain. If the brain is not abnormal, what type of abnormality is there? So that is one area where you can classify different signals. But what is one more? That is brain-computer interface. You look at here, brain signal EEG is received, features are extracted, then classification is applied, and then see that some commands are generated. What is the role of BCI? A robot is doing great work in the difficult time, COVID-19 time. How the robotic is doing that? Robotic is having cognitive ability. Let us understand, just like human brain ability. So with this technology, the technology, the interface called as brain-computer interface, the brain signals are received by the computer. Computer can generate the commands, and on the basis of those commands, certain appliances, certain applications can be controlled, can be run, can be operated. This is what we do in brain-computer interface. Now we are sending a lady robot to the space, to the, and we'll have interface from the ground. We can talk with her. We can get all the details from her. How? It's the example of human-computer interface. So when we talk about human-computer interface, it is similar to brain-computer interface. So BCI, what does BCI do? It acquires signals, analyze them, and translate them into commands. What brain thinks, computer will do now. Computer will mimic the human brain. BCI may be invasive, semi-invasive, non-invasive. Invasive means, and non-invasive means you put the electrodes, you do not insert any needle here. Any needles are not inserted, but simply put the electrodes over the skull. So that is non-invasive. So invasive, non-invasive, these methods are there. And what are the domains? What are the areas which are included in BCI? They are attention, formation of knowledge, memory, judgment, evaluation, reasoning and computation, problem solving, comprehension, production of language, NLP, natural language processing. How does your computer understand any language? How does it interpret and translate into any language? It has been trained by using machine learning. So this is one interesting diagram that depicts the cognitive ability. What are the abilities in human brain? Problem solving, reasoning capability, retention capability, recalling ability, ability to plan, ability for attention. And let us see one more picture that is even interesting. See, this is interesting picture. You look at the brain structure, and then I will correlate from which part, what type of signals are acquired. This is an interesting picture you see here. This particular area, parietal lobe, is speech and taste. So this part of brain can sense and detect speech and taste of anything. Then this particular area, which is called as temporal lobe, hearing capability, smelling ability, and the frontal lobe is speech and motor cortex. Motor means we move our eyes, we blink our eyes, we move our hand, and we know that how we are moving and why we are moving. Our body language matters a lot. For what purpose we are using what body language, it matters a lot. So those things are interpreted, those things are analyzed in different parts of human brain. So can we differentiate? Do we distinguish? Yes. How? Because all these different parts, with the help of different electrodes, emit different signals, and those signals can be interpreted and the analysis can be made. So this is one more simplification of the previous diagram. You look at the brain, that this area, I'm looking like a blue color. This includes visual, that is ability to see something, reading capability, understanding language, occipital lobe, that is, this is connected, the green color is connected with human eye. Then see brain stem, where basic life functions, temporal lobe, where memory capability is involved, frontal lobe, where problem solving, creative thinking, and the personality traits, these are involved in this frontal lobe. Now you can see one interesting thing, that in the brain structure, that is the brain, this anatomy, the different areas having different functions. Can we explore? Can we extract? Can we read? Can we simplify these capabilities? Yes. If we want to simplify, if we want to interpret these capabilities, how to do that? We need signal. We need signal, that signal which is generated or emitted by human brain. So nervous system, I will not highlight much on nervous system. Nervous system means, as I told you, we have more than 10 to the power 15 neurons, billions of neurons are there, and those are structured in human brain. So there is a sensory input. Sensory input means I see something, I recognize something. In the beginning, when I saw the face of Dr. Swati Dubey, I mean, I was so happy to see her after a long time. So how it is happening? It's connected with my brain. The sensory organ is connected with my brain. So the brain asks me something to do. Brain tends the body, the body parts to do something, to perform certain tasks. So therefore, the sensory organ is integrated with motory output, whether to walk or not, whether to move back or move forward, whether to go towards left or right. It's not done by leg. Leg is, your motory organ. Leg is your moving organ. So who is controlling that moving organ? Your brain. So is there any connectivity? Of course, there is connectivity. With that command only, everything is operating. So I don't know why I'm getting the prompts for admitting the guys again and again. I think the control has been given to me. Anyways,
because you are a co-host, that's why it's coming to you also. You just continue. You just continue with the presentation. Another host will handle it. Yes, sir.
Yeah. This is, I think, untraditional topic, which I think the participants won't have expected, to be such topic would be delivered in this lecture. And therefore, I can see the, participants are either losing, coming, joining, again, going. So that the prompt to admit is coming again and again. That is distracting, nothing else. Thank you so much. Okay, so this is neuron. So let us not explain neuron in much detail, but let us see that the neuron structure, which is the smallest cell, smallest cell in the human brain. And we have such 10 to the power 15 or more cells in human brain in our neural network. These days, everyone talks about neural network, artificial neural network. So what is natural neural network? Natural neural network is the neural network which is there in human brain, and it has millions, billions of neurons. And this is the structure of one neuron. So in one neuron, you can see that there is synaptic terminals, there is axon, there is synapses, and the synapse area, which is here near the synaptic terminals, you can see that it has small points, red colored dots are there. What are these inside the synapse in neuron? That is neurotransmitter. So every neuron, please understand, every neuron, its smallest, its dimension is very less, but every neuron has that capability. What capability? Neurotransmitting capability. It can transmit and receive the neurosignal, the excitation from sensory, and it can respond as well. So you can see dendrites are there, then stimulus is there, nucleus is there, cell body is there, and from these areas other neurons are connected. So all neurons are connected together and they form in layer. There are thousands of layers, hundreds of layers inside human brain. Those who nowadays every researcher knows about neural network. So you all know in neural network there are different layers, and today we talk about deep learning. Deep learning, more number of hidden layers can be accommodated, can be handled, can be managed. So all those hidden layers are what? Because in our human brain as well, we have a number of layers in which the neurons are organized, the neurons are structured. So brain waves, I will spend some time, maybe 5, 7 or 10 minutes on this, at least 7 minutes at least I want to give on brain wave. Here is the physics, why I was talking about physics. Oh. Okay, so BCI is the communication pathway between brain and external device. As I have already told you that invasive and non-invasive, in both ways we can do that. What are brain waves? Brain waves are the signals which are emitted by the brain, by human brain. Does it emit some signal? Yes. You think that, why we are advised to go for meditation. When we go for meditation, we keep calm and we try to be peaceful. And in that condition, your neurons get in some sort of rest condition. They're always active, but a lot of excitations will not happen. So therefore, the energy is always generated. And that electrical energy, that potential, which is excited by every neuron and then groups of neuron, then comes outside the layer, which we record as the potential. See here, what are the brain waves? What are the brain waves? And these are practically the waves which are there, which can be seen in any EEG signal. Let me tell you, in any EEG signal, look at delta wave, beta wave, beta, theta wave, gamma waves, alpha and mu. That is alpha, beta, gamma, mu, theta and delta. These are the waves which are actually emitted by human brain. The nomenclature is given that this is alpha, this is beta. What does alpha indicate? I will tell you. What does beta indicate? What does, the mu indicate? We will discuss. I will tell you. But these are the signals which are called as alpha, beta, mu, theta, beta. These are the brain signals. And what we can see from these signals, most importantly, all these signals, look at here, the frequency is very less, very less. There is some amplitude. You look at the amplitude, y-axis. But if you see the x-axis, and if you compare gamma waves with other waves, the gamma waves has comparatively more frequency. The repetition is more. If you go to mu, it also has certain frequency. If you go to delta wave, the frequency is very small. Frequency is very small. So let us see the delta wave. As you can see in the previous slide, delta. Look at the delta wave. And now if you go to the next slide, delta wave, the frequency range is 0.5 to 4 hertz. You can imagine the frequency is very small and has highest amplitude among the other waves and lowest frequency. Go to the previous one. The amplitude is highest. The excitation is very high, but the slow excitation. Slow means the frequency is very less. These occur, delta wave occurs in adults and posteriorly in children and are primarily associated with deep sleep. When the adult is in deep sleep, that time the delta waves are, normal delta wave is recorded. Theta waves, look at theta wave, slightly larger, that is 4 to 8 hertz, and normally observed in young children. And in other children, older children and adults, these waves are observed in a state of drowsiness or arousal as well as in meditation. I told you already, if someone is in meditation stage, that to which age group, children or adult, older children or adult, what is the frequency range? 4 to 8. And when this signal is recorded, when this signal is observed, under which kind of activities? These are some examples. Drowsiness, meditation are the situations where this type of signal is recorded. These waves may occur anywhere, are not related to the task at hand. An excess of theta waves may represent abnormal activity. If more number of theta waves are coming, because it can come from any part of your human brain, any part of the human brain. So if excessive waves are there, theta waves, it's not normal. A normal human brain, it is not excessive in number, but when there is excessive number of theta waves, it means there is some abnormality. What is that abnormality? Is again the matter of research, the study of research. Alpha waves. The alpha waves lie in frequency range 8 to 13, now higher, and associated with wakefulness, closing the eye, effortless alertness, creativity. When someone is engaged in creative activity, creativeness, creative activities, closing the eyes, effortless alertness, the waves which are, the patterns which are generated by human brain are alpha wave. These waves normally appear in posterior half of head and have higher amplitude over the occipital. Occipital is the vision area, frontal area. Beta waves, that beta waves in the frequency range of 14 to 26 found only in normal adults. These waves are correlated with active attention, active thinking, solving critical problems, focusing on outside world, and therefore also known as sensory motor rhythm. Because when you are solving some critical problem, active attention, you are paying active attention means your motory organs, your hand, your mouth, your nose, your eyes, your ears, all are very active. So motory organs, they are active. So they have that rhythm. The beta waves are low in amplitude and normally under, see the amplitude. Amplitude is very less, 30 microvolt. Can you imagine? The amplitude becomes very high. Can you imagine? The frequency is high. If frequency becomes very high, the brain will blast. So therefore, the signals which are generated inside the human brain, we know that we have millions of neurons. And all those neurons, if they generate high frequency signal, what will happen to brain? The brain will collapse, the brain will just blast. So therefore, the signals which are generated by human brain are all very, very low frequency, low amplitude signals. Gamma waves, 30 hertz up to 100 hertz, help to determine binding of different populations of neurons together. They occur during cross-modal sensory processing, the process of combining different senses such as sound and light. When we sense sound, light, these are sensed with the help of gamma. Mu wave ranges from 8 to 13, mixed with other waves and sometimes overlap with other rhythms. It shows synchronous firing of motor neurons over the sensory motor of the cortex. So what I am trying to make a point for young guys, the researchers who are doing good research in physics or who want to do good research in physics, it's not like that there is elementary or basic physics where you need to characterize, where you need to study the characterization of physical materials and physical properties. But there are some advanced topics, some advanced physical phenomenon that could also be studied, that could also be researched upon. That is my intention for through this lecture. So this next one is active potential. Those who have understanding of how the potential is developed, those who study this p-n diode and how this cut-in potential is developed, threshold concept is developed, those who they will take much interest in developing the active potential. But you can see here the active potential is generated as sodium ions flow in one location along an axon. The depolarization spreads to the neighboring region. You can see the sodium and potassium ions and the membrane initiating the acting potential there. Look at here from this situation. Now the movement starts from sodium, and since the movement is there, so drift is there. And whenever there is a drift, you know that drift causes some electrical field. And whenever there is electrical field, we define electrical field as negative potential gradient, that is minus dV by dx. So therefore, some potential will be generated, potential will be produced. So as I told you, all neurons, all layers, they produce some amount of electrical potential. It is not as simple as it is looking. There is a phenomenon of electrical potential generation. If you want to study how potential is generated in human brain, in neurons, it will take hours together to understand. But I'm just trying to highlight a potential is generated because of ions present. You might have heard that in a brain of some particular person, the amount of sodium, the ions is very less. So therefore, the behavior is abnormal. So there are some ions, because of those ions, the different ions, the potential is formed, the potential is developed, and we get the electrical potential. This is something which is further described from the previous slide. I will discuss the last one only, where you can see a firing. It crosses the threshold value. After resting potential, it crosses the threshold value. After you see threshold value, it goes till some peak value. And what is that peak value? That is the amount of excitation. Because at certain level, threshold level, offset level, no firing will happen, no excitation will happen. But when it crosses, when will it cross? When the potential will cross? When the neuron is engaged, when the neuron is busy in some activity. What activity? If I'm angry, I'm busy in angerness. My brain is engaged in anger. My brain is engaged in happiness. So in all moods, in all different status of the, the human brain, the excitation will be different, and accordingly, different signal will be generated. So simple. And different signals represent different status. And accordingly, whenever there is abnormality, some abnormality will be recorded. So this is the next part, which talks about EEG recording. I think the diagram is enough for you. And those who have heard about EEG, those who have some knowledge about EEG, they know that how EEG is recorded. They'll put a cap-like structure. You see in the diagram, cap-like structure, and there are so many electrodes. And I was telling you, all those electrodes are connected with wires, and those wires are channels. So in the problem, I was telling you the selection of channels, how many optimal number of channels, which channels are more important. These are the research problems. So, but this diagram represents the electrical EEG recording. And can you see that this recorded signal, when it is seen in the computer monitor, computer screen, it looks like this. So there is a system, electrodes are placed on the scalp with paste, some paste, wet or dry. Even with ECG also, you know that ECG of chest, the wet material is applied there. Why? Just to establish the connectivity, just to provide the connectivity of the signal to the device. So the electrodes are placed. Those electrodes have diameter of 0.4 centimeter to 1 centimeter, could be invasive, non-invasive. I have already explained. I think I am, I have 45 minutes, so I'll be completing in 5 to 7 minutes. I believe 45 is given to me, and 10 or 15 minutes is for discussion. So I'll complete in next 10 minutes. So brain and EEG signal. Look at this diagram. There are two different standards to record. 10 by 20, 21 electrode placement. These are the technicalities of acquisition system. But what we can see in the diagram, all these are different electrodes which are placed in order to record the electrical electrical signal. Yes. And what those electrical signals are? Those electrical signals are your human brain signals. So this part was on brain physics, brain signal physics, brain electrical signal. The next part, I will not take much time. As I told you, now we have brain signal. We have biomedical device. We have biomedical equipment, EEG recorder. Now we have EEG signal. What is next? How will we analyze? We need some signal processing method. We need some machine learning method. So next part, I will finish quickly. Signal acquisition and processing techniques are needed. Machine learning techniques are needed to train the signal, to understand the signal, to interpret the signal, and then optimization techniques to further improve the performance of different classifications. So we can see that image acquisition. What happens when we acquire the image? There are different problems, and the problems may be artifacts, the noise. You are capturing the signal quality is not good, the waveform pattern is not good. Can you do it correct? Yes, by having good setting and suitable pre-processing method. So in signal acquisition, setting of the device is very important thing, like high sampling rate, high signal to noise ratio, attenuated noise and movement of artifact, accurate and fast electrode localization. If you do not place the electrodes properly, the signals which are acquired won't be proper. So there are certain precautions which are to be kept in mind while acquiring the signal. Sampling rate in the device must be set high. In you all physics people understand that why sampling rate is to be high. More the sampling rate, better is the signal quality. Because if you increase the sampling rate, more number of samples, better quantization will happen, and the signal quality is always more. Otherwise, aliasing and other difficulties come when there is a undersampling. So sampling rate must be high. Why signal processing? Because when we acquire the signal, there may be problem called as artifact. There may be problem called as eye blink, ocular artifact. Let me tell you, when the electrodes are placed over my scalp, the doctor will suggest you do not move. Just be silent for some time. But you started moving your eyes, you started moving some part of your body, then that signal will definitely get distorted. The signal will be same. You are happy and you are moving eyes, but you are not becoming angry. So it will record the signal for happiness only, but the signal may get some distortion. The signal may get something unwanted signal mixed with, that is called as artifact. So those things are there, and how those artifacts, you are bringing your signal with the power line also. So in the power line also, electrical cable also, there may be some signal, there may be some problem, unwanted signal that can be mixed with the original signal. So that also has to be removed. That also needs to be pre-processed and has to be corrected. And for that, signal processing is important. Principal component analysis. There are different types of filters, low pass, high pass, statistical techniques, Kalman filter, right? Fourier transform. There are hundreds of different methods which are available. You can see the picture. The red color is a clean signal, whereas the blue color is a raw EEG signal. When we capture the raw signal, you know, the signal which is original signal, it is distorted. So when you pass through some signal processing, it becomes the color which is highlighted here is the red color. And that looks like any of the waves like alpha, beta, gamma, mu, theta, and beta and delta. Feature extraction. Feature extraction is needed until you get the features from your signal. So what is the next step? You have to extract the features. The appropriate features need to be extracted. We can extract what are the different features: wavelet coefficients, power spectral density, entropy and variance, statistical features, time domain features, amplitude, energy. You all understand very well. If there is a time domain signal, we get the electrical signal which is in time domain, having certain amplitude and frequency, or amplitude in time. You can convert the signal into frequency domain also. You can get the power spectral density. You can calculate the energy value. You can calculate the mean value. You can calculate the variance value. You can calculate a number of other factors. The statistical features you can extract when you convert your time domain signal into frequency domain. So this is the area, the feature extraction, which is applied in order to address the problem of high dimension and appropriate feature extraction. That is feature extraction and feature selection. Then machine learning, deep learning, neural network. Deep learning is the most current, most advanced and emerging method of machine learning used for training a lot of data, medical data, any kind of data, signal processing data, or any kind of other data in different science and engineering applications. So those data are interpreted by the patterns are there, the signals are there, they are interpreted, trained and simplified using some machine learning methods. As its name suggests, machine learning, machine learns it. In it trains the signal, and after training it, it understands what the signal represents. That's machine learning. Is just like human learning. How do we learn? We train ourselves. How do we train? Our neurons get activated, and we use all our neurons in a thinking process, and we train and we learn something. So similarly, the neural network model or any other model will train itself, will understand the data with the help of any type of method called supervised learning, unsupervised learning, semi-supervised learning, and there are hundreds of modern machine learning methods. Any of the suitable method can be used and can be trained. So as I told you that optimization technique, that there are different methods which can be used to further improve the performance. What are the appropriate features which are important in classification? Which is the most appropriate machine learning method? All these come under the optimization techniques which are needed. And then finally, as I told you, I promised you, I will conclude by issues and challenges. Then I will go to my thanks slide. Issues and challenges are my last slide. Do not worry, I'm concluding. Poor signal to noise ratio and artifact are the problems. When SNR, you all know SNR, signal to noise ratio. When noise component is more, the desired signal is less, so SNR will be less. So poor SNR is a problem. Implantation of electrode, how appropriately it has to be implanted, that's a research problem. High dimensionality of data, a large number of features. We get so many waves from different channels. Information transfer rate and selection of channels, how many optimal number of channels, which area more channels, which area less number of channels we need to deploy. Variation between different individuals. As I told you, that's cognitive assessment is sometimes subjective matter. So It varies from individual to individual. So that's another problem. Difficulty in obtaining precise and accurate results because brain is sensitive and complex. Because brain is very sensitive and complex. It's very, very difficult to understand complex phenomenon of human brain. But thanks God to the technology, thanks God to the modalities which are present, EMG, EEG, ECG. These are the modalities, right, which are used in order to understand the brain signal and come to the conclusion, so that a lot of people can get benefit of analysis of human brain disorder, sleep disorder, or any other abnormalities which are present in the human brain. So these are the references which are, you can see from all IEEE or high quality elsewhere journals I have included. And that's all. And since this is physics, but this equation I have not put here because I'm lecturing in, for the Department of Physics. This is my popular equation, which is used in all my presentations, equal to mc square, because in my understanding, I have interpreted, you can say kind of, vague research. E is excellence, M is motivation, C is commitment. If motivation is there, what is more important and what is actually important is commitment. If C is half, you can see here, if someone is, some work is being done half-heartedly, your excellence will be 1/4. And if it is done doubly committed, someone does it with double commitment, no one can stop that person to have excellence 4 times. Because in my understanding, I believe that, what is important is excellence. Success is an intermediate stage in any research or any endeavor. What is important for all of us is excellence. In order to achieve excellence, in order to move towards excellence, we always try to develop appropriate competence in us. And I can tell you, research and research activities help us in developing so much of appropriate competence in all of us. So with this, I believe I did justice to the topic, and I hope I have not been reason for pain to all of you, and few of you would have enjoyed the lecture. So thank you so much once again for inviting me, giving me this opportunity. And I'm very happy to get connected with, the Ujjain Nagri itself, and that too with my favorite madam, Dr. Swati madam, who is very much adorable, very humble person, very simple person. In addition to very intelligent, her simplicity and humility is appreciated everywhere. I have been very lucky to have worked with her for some time. Thank you so much, madam, for inviting me.
Thank you so much, sir, for your excellent talk and excellent flow also. You are not changed. So please, Sai Shikha, now please proceed for question answer session.
Yes, ma'am. Thank you so much, sir. Very first question is it possible to correct the sleep disorder?
Yeah, of course. See, why in the different, the places where people go for meditation and different, the treatment centers where they are subjected for specific activities, and with the help of those activities, that the disorder can be repaired. Repairment is possible. I'm not a physician. I'm not a doctor, but as a researcher, I can say that the activities, the different activities can change the mental disorder, can change the mental status. And therefore, if there is stress, it can definitely be cured. It can definitely be repaired.
Okay. One more question is there. Auto recovery of brain stem cell is possible or not? If any physical defect occur in a stem cell, will brain recover the cell automatically or not?
I do not have any idea about this. I'm really sorry, because my focus is the signals and the analysis, and the use of the analysis and different applications of the cognitive assessment. So I do not have any idea at all in that area.
I think Professor Karmakar, Pralay Karmakar from Assam. Professor Karmakar, would you like to ask your question, or shall we ask from your behalf?
Madam.
Yes, please, sir.
Yeah, please
go.
ask. Yeah, please ask.
Okay, I will ask your question. Sinha sir, he asked that what are the active factors controlling the amplitude and frequency of the distinct classes of brain waves, and what are the active factors controlling the amplitude and frequency of the distinct classes of brain waves?
Okay. See, as I told you that you have seen the different waves which are there, and all waves, beta, alpha, beta, mu, theta, they have different amplitude and different frequency, and they also represent different status of human brain. So what I can say that when you are happy, suddenly you are angry, and then you start sudden, movement of your human eyes, started blinking your human eyes. So all these factors affect the amplitude and frequency of your signal, and accordingly different patterns are generated. Otherwise there is no any other factor which is there that can affect, but the activities where the human brain is engaged. You are in different mode, you are in different status, and accordingly the different amplitude and frequency will be, that potential, this is a matter of excitation of neuron. When you do something, when you are angry, the excitation of neuron will be different. When you are calm, when you are in meditation, the excitation will be little lower. And therefore you could see that the amplitude and frequency are lower when you are in meditation or in drowsiness, or when you are in asleep. But when you are critically thinking, doing some problem, that type your amplitude and frequency are going high. Because when you think something critically, you apply a lot of your stress to your human brain, and then you think about it, attempt to solve it, and therefore the amplitude and frequency will vary. Probably it will, and it goes high. So these are the factors. Activities are the major factors.
And he asked that what is the basis of the brainwave classification, such as alpha, beta, and so on? Is there any basis of classification?
No, see, since the beginning, when biomedical research started long back, there are books and research and articles which are there. So somewhere you have to classify, somewhere you have to give some name. So when in the biomedical beginning, initially biomedical research started, these were the nomenclature which are approved in the medical science as well. So those who are doing the neuroscience research, neuroscience department, they also interpret these waves as alpha, beta, gamma, not only research. So these are the standard waves which were introduced in the biomedical field as the waves of human brain.
Another question is,
but in the research, sorry, madam, but in the research, it was established that which particular wave represents which particular mental status. Because when someone is happy, that time EEG was recorded. When some person is sleeping, that time EEG was recorded. And then it was observed that during sleep, during happiness, which wave is present, which wave is observed.
Oh, it is very interesting. And Dr. Venkatraman from
I have one more thing.
Yes, sir. Please.
Yes, I have one more question. So as far as seen, all these distinct classes are different only in terms of frequency and amplitude.
Yeah.
As far as seen from your slides, that alpha, beta, gamma, all these distinct classes of brain waves, these are different in terms of amplitude and frequency only.
Yeah. But as I told you, the classification, the analysis of cognitive assessment and cognitive ability is not done on the basis of amplitude and frequency. There are hundreds of other features which are extracted from the elementary signals. The elementary signals are alpha, beta, gamma. Analysis is never made on the basis of amplitude and frequency. The analysis is made on the basis of hundreds of features which are extracted by employing suitable machine learning to the signals, that is brain signals.
Okay, thank you so much, sir. Thanks.
One more question is from Dr. Venkatraman. Is it possible to extract the memory and thoughts from brain waves?
Yeah, it's there, madam. I did that work. In our research work, we analyzed, we applied deep learning, and that I was highlighting in during while I was presenting. We found that as far as memory is concerned, memory has different memory is a different attribute than the thought process. Thought process is entirely different, but memorization is entirely different thing. In memorization, we did one study where we found that paper can be, and a basic paper can also be Googled on my name. You can type like cognitive ability of human brain by G.R. Sinha. It's there in the Springer. So we included a number of people, and we found that for female, the memory capability, the memorization and recalling capability is high. Whereas we did it for different age groups also. We found that lower the age group, better is the recalling capability. As far as the thought process is concerned, thinking process includes critical thinking, problem solving, reasoning capability, planning, and these are the different activities which are separate from the memorization and recalling capability. We call it as rote learning.
Thank you, sir. Just so that I can continue with my question. See, the memory is like when we re-extract or maybe reconstructing, how, in what language the particular person, see, suppose a person, he records his memory in one language particular. Maybe that is in his own operating system. What do you call it like? See, when you decode it in the, maybe in a machine language, how to get the signals, like how do you reconstruct it? The capabilities are something different. What I'm talking about, the software which has been embedded in the particular person's brain. So the signals, how they do, how do you classify those kind of signals like which are in the memory?
No, sir. There was a process. There was a process. All the subjects after time they were asked that, you know, who is this picture, what is this picture, who is this person. So that was one data, and other data was when they were seeing those objects and when they were being asked the questions. In both the cases, EG were recorded. Number two, the data was physically collected, that whether they are recognizing correctly or not, and it was correlated with the EEG data, and then
okay,
the EEG data was trained, and then it was concluded that the please go ahead. We can take one more because I have lecture here. After 20 minutes I have a lecture here.
So, sir, I think we should end this. Enough questions have been there, and it is very nice to hear from you after so many years. And once again, very much thankful. All of us, we are very much thankful to you for your graceful presence. Thanks. There is some connectivity issue with you, sir.
Thank you so much for inviting me.
Thank you. Thank you, sir. So thank you, sir. Thank you very much. Now I would like to once again call Dr. Venkatraman from Devi University. Sir, please give some your inputs and suggestions, because this is our first time to arrange this international webinar, and naturally there were different experiences of different persons involved and attended in this webinar. So please share some your suggestions and feedback.
All the 5 speakers are amazingly too good, right from the Yogi Saab, then Kanal Saab, today Jamil Saab and Zubedi and Professor Sinha. I enjoyed all these lectures thoroughly, and each lecture is of its own kind, like they are of different nature. So this is one of the beautiful, like, as well as see, we are all cyber immigrants. None of us are all cyber native. We are all learning process. So this is online lectures, online thing, everything is new for us. Like this pandemic situation has brought us, like, in all decisions, this is fantastically flow. This whole webinar arranged very well, excellently. All the 5 speakers who spoke about, very informative. Enjoyed thoroughly from my end. There is nothing to say. Since all the 5 lectures are very interesting, what I wanted is these speakers, they can give a small write-up about each lecture. That will be very interesting to learn, even for new young students also it will help. As far as for me, person like me, to understand much better, like to go for it. Like, So I request all the speakers to give a small write about their lecture and what are the further cases like that. That will be very helpful to us. Thank you, ma'am. Thanks to all of us.
Thank you very much, sir. Some of them have already given their abstracts. I will share it to you. And anybody who wants abstract of their speeches, invited talks, I will share with them. So thank you very much once again.
Thank you, ma'am.
Now, Sai Shikha, you proceed for the next.
Thank you, ma'am. Now I will invite Dr. Nishchhal Yadav, sir, convener of EIPT 2020 for presenting a valedictory report. Over to you, sir.
Hello, I am audible. Hello.
Yes, sir, you are audible and visible too.
Yes,
Carry
sir.
on, sir.
Myself, Dr. Nishchhal Yadav, and I am feeling very great to present the report that this international webinar on emerging interfaces of physics and technology, EIPT 20, has been a great success. This webinar has succeeded its objective of providing a platform to physicists, scientists, researchers, and technologists from different parts of the world to discuss their latest innovative research ideas and most recent technologies. Being a fifth EIPT event in our series of 3 national and 2 international events, this was special for us because of its virtual nature. More than 500 participants from USA, China, Bangladesh, Egypt, Myanmar, Pakistan, Nepal, and India have enthusiastically registered themselves to be a part of this international webinar. I much appreciate the lectures from Professor Arup Niyogi sir from USA, from Professor Raju Khanal, Nepal, Professor M. Jamil from Pakistan, Professor Deepak Subedi from Nepal, and Professor G.R. Sinha from Myanmar were kind enough to accept our invitation and deliver their fruitful talks. In addition to this, we have responded all the queries of our participants during the sessions. Such an event was planned and implemented with the expert advice of Professor S.K. Ghosh, the former Vice Chancellor of Vikram University and our mentor, and under the patronage of the Professor Balkrishna Sharma, Vice Chancellor of Vikram University, Ujjain, and Professor Shubha Jain, Dean of Science Faculty, for their graceful presence and support. I am also thankful to our advisory Professor B.D. Srivastav sir, Professor R.K. Chellani sir, Professor G.K. Upadhyay sir, Professor S. Mukherjee, Professor Giriraj Sharma sir for their kind help and for making this webinar possible and successful. I am also much thankful to the virtual presence of the research scholars and PG students of the reputed institutes have made the program more relevant. Actually, now we can say that these activities, this adverse time of pandemic has been a boon for all of us from the point of view of knowledge gain. With these words, and hereby end this report of the webinar. Thanks for joining us. Thank you and be safe. Over to you, Saishika.
Thank you so much, sir. Now, feeling gratitude and not showing or expressing it to other person, it's like wrapping a gift and not giving to that person. So for Thanksgiving, for vote of thanks, I would like to invite Dr. Ganpat Ahirwar, sir. Over to you, sir.
Hello. Thanks, Saishika. Thank you is the best prayer that
Yes, sir,
anyone
yes, sir.
could say. I say that on a lot. Thank you expresses extreme gratitude, humility, and understanding. A very good afternoon, everyone. It's my privilege to propose a vote of thanks on the occasion of end of second session on second day of this international webinar EIPT 2020. With the sentiments of gratitude, let me extend a very hearty gratitude to patron of the event, our Honorable Vice Chancellor, Professor B.K. Sharma, who has been a constant source of inspiration for us, right from the conception of the im- implementation. His support and guidance has been there with us. On behalf of organizing committee of EIPT 2020 and entire fraternity of physics and technology and my own behalf, I extend a big thank to chairperson of this session, Professor S.K. Ghosh, a renowned physicist and former Vice Chancellor of Vikram University, Ujjain, for his graceful presence and guidance. I am also very grateful of Professor Ujjain, Dean Faculty of Science, Vikram University, Ujjain, for her precious word, elegant presence, and for sharing some time in spite of busy schedule. Also, I would like to thank Professor B.D. Srivastav, Professor R.K. Chajlani, Professor G.K. Upadhyay, Professor S.B. Srivastav for their graceful presence and guidance. I would like to take this opportunity to place on record our hearty thanks to our invited speakers, Professor G.R. Sinha, Professor Arup Niyogi, Professor Raju Khanal, Professor M. Jamil, Professor Deepak Subedi, accepting our invitation for their excellent talks. Further, I also wish to express my gratitude to Dr. Swati Dubey, H.O.D, School of Studies in Physics, for the perfect logic support and guidance she has extended to all of us. Well, an event like this cannot happen overnight. In fact, the wheels start rolling big ago. We have been fortunate enough to have a team of very motivated and dedicated young faculty members of our department who know their job and are results oriented. I really salute the involvement and willingness of all the student participants, faculty members, and researchers who joined this webinar with zeal of learning and grasping state of the art scientific ideas and theories presented and discussed on this platform. At the last but not the least, I convey a big thanks to press and electronic media for wide coverage and publicity. Thank you. Thank you. Hello.
Hi, Shikha. इसको म्यूट कर दिया. Sai Shikha.
Hello.
Okay, thank you very much, sir.
Thank you. Thank
I'm
you.
there
Shikha.
only.
Yeah. Please proceed. Thank you. Thank you for
Okay,
nice
now
vote
one
of thanks, sir.
Thank you. Thank you.
Now, one announcement is there for all of you that certificates will be provided for those who filled the feedback form and attended the webinar. And thank you so much once again, Ahirwar sir, for you and for all the speakers and participants. Over to you, ma'am.
Okay. So thank you very much, one and all, for joining this webinar. And I hope this excellent chain of interaction will continue. And we will again meet. Hope for the better future. Be safe. Stay at home. Thank you. Thank you very much for joining us. You may leave now.